Or am I 6?
All right. Welcome, everyone. It's April 8th, 2023, and we will have our Zoom meeting today with an exciting schedule. And let me see if I can share what I think we will do. So that's it. We will have the elevator or lift, depending on where you live, challenge, and Peter will go into the details, and then we have some presentations from Wolf, from myself, from Bill Ragsdale, a talk, and Cecil will talk about how to write your own force in C. Later on, there's the coffee break. I don't know whether we will do it, but we decide on the fly. So that's it. I will hand over to Peter Jakacki, and then he will introduce us to the lift challenge, the elevator challenge, and we will see. Peter. So somehow you're, there you are.
Yeah, so we're coming through good. All right. So just, yes, it's just been a busy week, and I just got back. It's just after midnight here, and had a quick little nap. So excited. I had to have a coffee though, get charged up a bit more. But what else will give me a lift? Well, the lift challenge. And so we had a lot of entries so far. And you know what? The exciting part of it too is that it's only just started as well. So today I'm going to just take you through. I haven't had a real good look at these yet because they've just been coming in. I haven't had a lot of time. But what I'm going to be doing is inviting the contributors to also talk a bit about their experience as well. And so who do we have on here first here that we can have a look at? I've got, I'll just get rid of a couple of screens here so I can share some other things here. And hopefully, yes, well, okay, that's all right. We'll get there. All right, so what are we sharing first? Who'd like to, I'll introduce you first, but who would like to be going first? Any hands up here at all? Just make sure I've got my screen adjusted here, right? So for instance, I've got, oh, I don't know what's happened here. Something's happened. Atlee, okay, this thing's complaining at the moment, but we'll get to it. All right. Just a second, just make sure that everything's right up here. Now, okay, so we have entries here from Atlee, from Christian, also from Francois and George Philippa, and James Norris, Matteo, Pablo, Peter Forth himself. I have an entry there too, and Travis and Vladimir. So what we're going to do is perhaps we can kick this off. Who would like to say a few words about their challenge first, how they found the experience? Otherwise, I have a few videos I can probably show you of these experiences.
Personally, I liked it a lot because it didn't require extra hardware or anything or a specific platform. And I learned a few things, and it's basically a lesson in humility. That's what it comes down to. And it's not finished because, yeah, I have a working solution, but it's not something I'm extremely proud of, and I think it can be done more simply. So I'll continue working on it. I loved it, actually. I spent a lot of time on it.
Yeah, so
I hope it will show. Are you going to play the videos we sent you?
Yeah, I'm just trying to find out what's going on here now because I just managed just to get back before and just hook everything back up here. So I'm just checking to see the video that you sent me because everybody sent me their videos and I've got them all here except something is going on here at the moment here.
Peter, may I say something very shortly?
Yes.
I will show later the physical model of an elevator, and I will have a divorce if I don't stop playing with this elevator.
Oh, so you're still playing with it at the moment, are you? You're saying? Yep.
So I guess maybe I have a dumb comment. Wouldn't you have two variables? One is current floor, the next one's next floor, and you just subtract the two, and then you move it into current floor, and then what is the difficulty about this elevator thing in the algorithm? Maybe I'm missing that.
I think Francois, Francois had a few words there. He says it's a lesson in humility. We think, oh, there's nothing to it. You know, you just go from floor to floor. When we start coding it and simulating this, what we're finding is we have to take into account that, you know, it's not just one floor that we go. If it's just A to B, then we do as, you know, one did, we just teleport, right? But what we're trying to do is service the requests. We're going in a particular state, we're going up or down, or perhaps we're even just idle at the time as well. And then, so there's a little bit of logic involved in that. Francois, did you have a few words? I just saw you unmute there before about that in reply.
Yeah, it's not that simple, Don. It is essentially, it should be it's a scheduling problem, obviously. And I went through a static scheduling solution with fuck up prevention, essentially, which is not satisfying. I think the correct solution would be a dynamic scheduling scheme in which yes, you have scheduled stops, but they can change depending on the inputs to the system dynamically. For instance, the elevator goes down and you have a call at a lower floor. So you have to update your schedule to reflect that. Now, if it's a call to go up and you have another call to go up at a lower floor, you must skip that floor. So it's a dynamic thing. And I think it should be programmed that way, although I didn't. Just this fuck up avoidance, which really works well, but it's not satisfying. That's all I have to say on the topic. As long as it works, you know.
Yeah.
It may not be 100% elegant and short and sweet, but yeah, does the job.
There's many different approaches to this, as we've seen from the code, and also the implementations in different forths. For instance, I'll just see if I can bring mine up, because what I'm just doing is, as I said, you know, we always have these last minute hiccups here, but I'm just checking to see what we've got here. And I'm trying to find your video, Francois. I've got your code there, and what I might just do is just bring that up here, and then just share the code that we've got here for yours. And so I'll just share the screen here. Okay, trying to get all this to work properly on here. Share this part of the screen, which is right there. Just a second, we'll get this right. Now, for instance, my particular version, I went and okay, see if we can change this window here. Here we go. I think this one is the one we've got. Okay, so the only trouble I've got now is the trouble I always have with this. Okay, so you can see all that okay, and
this is 2-day-old code, by the way.
Okay, all right. So
it's been improved since.
Yeah, yes. Well, would you like to comment a little bit about this? You have all this up here as well, all these fine bits up here that you've added extra in there.
Yeah, the purpose of this is to support not just my own forth, but also GNU-forth and VFX-forth. So these are some sort of one-line conditional compilation directives. You see, the key is up there, the postpone backslash, which enables or disables the following definitions, and they must be one-liners. I got this from the fourth 2012 test suite, and it's really convenient when you don't have bracket if, bracket else, bracket then, which I don't.
Okay, all right.
So this is all for portability purpose. This is all ANSI compliant stuff. Yeah.
Oh, okay. All right.
The whole code, yes.
So that's pretty much just extending that just to adapt to the system. But going into your variables and constants, I see here that you've got different variable constants, etc., for whether it's down or up, etc., defining all these things. And what you have, and something similar that I have, okay, I have variables for all the up requests, the down requests, and the schedules, or the call buttons, as they call them. I think they call them, the call buttons up and down. You call the elevator, and then we also have whatever the destination is, etc., as well, schedule stops that we have that is selected from within the lift itself. So we've got that in there, and also the actual logic of it. Let's just always go down to the very last part of the fourth file, see what we're doing. And can we see this okay at the moment in there? We can see this. I'll see if I can make it a bit larger.
Yeah, the basic algorithm is essentially the one you specified in your specification document, except that I moved the query buttons up from your schedule for practical reasons. Yeah, I think you had the buttons at the very bottom. The query buttons, you had it at the very bottom. I moved it up before compute. Before the logic is we get input from the buttons, the sensors. We carry them into compute, which updates the schedule, and then step actually decides what to do: go up, stop, whatever. That is the logic, and there's a feedback mechanism from the step routine to actuation of the sensors. I call it like that because we essentially acknowledge at the very end, we acknowledge the up and down requests.
Okay.
So there's a feedback loop of sorts.
Yeah. Okay.
And
I see that there. Yeah, and there's the acknowledge part there. So
yeah, that is very important. Yeah. Oh, there is the fuck up prevention mechanism. You see the bypass stop at current floor?
Yes.
This means that even if a stop is scheduled, we may have to ignore it and not stop. But this is only because this is not dynamic scheduling. This is static in that once a floor is scheduled, it stays scheduled, even if we must not stop there.
Yeah. And that's what I found. I just basically created a series of latches. In fact, I went a step further and went from bit flags over to byte counts. So if you press the up button, or for that one, I just count them, even if I only really wanted to know that it was 0 or non-zero, just for internal use. So I thought, well, that might be useful for later on. So I did something similar there, where we have those variables there. Now, you sent in a video, did you say? Because I can't find it anywhere. I've just went and looked through here, and I've got videos for everything else. I'll have to see whether I've got something there for did you send one in, Francois? Or? Yeah,
I did send it last night at midnight my time. About, you want me to
on-
resend it or?
Well, perhaps you'd like to share that one. You would like to share that and with us, and I'll stop sharing here. Do you have that handy?
Yeah, sure.
Okay, that'll be good. Yeah.
Hello, this is Francois and this is my entry for the lift simulator. Sorry about that, technical difficulties. I'm not used to the presenter mode.
This is good because we can everyone can have a little go at sharing and presenting, you know, just for a couple of minutes with this.
Share screen, but I just want to share a window. Can I do that?
Yeah.
All right.
That's it.
So, yeah, we see your fourth screen.
Hello, this is Francois and this is my entry for the Lift Simulator Challenge of the 4th 2020 Facebook group, April 8, 2023. So I am using my own Forth for this exercise. It's also running on my own hardware, which is based on the Hitachi 6309, more modern implementation of the Motorola 6809. It runs at 4 times the speed, it uses less current, and it has an extended instruction set, which makes it very, very interesting as a platform for implementing Forth. All right, my code fits in about 500 lines. More than 50% of that is documentation. And that comes down to about 35 Forth blocks, which I am loading from Compact Flash Mass Storage. The huge 64 megabyte Compact Flash. I mean, it's huge by comparison to what was available when I developed this stuff. And at the time, that was 360 kilobytes of floppy disks. And I didn't even have that. I had only a cassette tape recorder on the TRS-80. So yeah, I wrote this original Forth implementation for the Z80 and ported it a few years ago to the 6809. All right. So this is my simulation. We're gonna test first the basic test case. Please, like one down. Oh, it's one up. Well, it's also another operation from the first floor. One down, 8 up, 1G. All right, this is all properly ignored. We're going to the 8th floor. And let's suppose it's going to go down. So here it's favorable because we see that there is no scheduled stop on the 6th floor because we have a higher calling sort. So that's good, but it's not always the case. So my software is obviously perfectible, but for practical purposes, it all works okay. I have countermeasures implemented. Let's say now we want to go down to 2 on the 6th floor, and in the meantime, on level 4, down and 4 up as well. So on the way down, only the cool down is cleared, which is fine. And down. And you don't like to the elevator, so we have to go to ground level. 16. On the way back up to the cool up from the 4th floor with the gates. The log area at the bottom, I think, is very useful, not just because you can trace history, but you can also use it for debugging purposes, which can be useful because this is not simple software. Or,
Francois, what is it doing now? Is that going okay down to?
It's not even scheduled, so there's no chance. So this is scheduled because we have a direct go from the cabinet itself. But it works fine, as you can see. And even possible things like 12 go, it's discarded. When you don't escape, stack is empty. The return stack is empty as well. And all the memory used by the program is removed by the use of the standard ANS 94 marker word. So 68 and on the fresh root, it's the same thing.
I'm having trouble with the audio here for some reason. It's been coming through very muffled once you started
All right,
sharing. You're not speaking to the
Wraps it
mic.
up for me. Thank you.
Yeah. So, but what we might do is, yeah, so we've only got a limited amount of time. But what we might do is just come back to you later on. We'll see how we go with things. But thank you for your entry. But remember, keep on at this with part 2 of it, and to really refine this. That's a really good start that we've got so far. And you know what? We can cheat now because we can have each other's code as well. We can look at, that's a good idea. So we can borrow and refine this as well, and look at the next one. So thank you very much, Francois. And for the next one, what I'd like to do is, who would like to be up next? And I'll just bring up the code there for that one as well. Any volunteers? Otherwise, I'll just present one. Christian, okay, Christian, you had a big document on that one there. We'll come back to that later. Atlee, are you there, Atlee? Yes. Atlee there? Now I can see Pablo. Pablo, you're there. So how would you like to? I don't know what this is doing at the moment. I've got this up in Visual Studio Code, and it's not coming up here properly. So I'll just bring this up. I'll share the video from Pablo, and then I'll get. Okay, right, there we go. Okay, so I'm going to share this video right now. So bring this up here, stop that for a moment, and then share this. Okay, so here we go. And feel free to speak and comment on the operation of this too, Pablo, if you don't mind. So I'll just share this part here. Okay, I think this is the one. Okay, it looks like it, yes. Right, so you can see that okay, and let's play that one. Looks very good, very nice, smooth. So you're clicking the 1 to 8 for the lift buttons. Are correct, Pablo? Or? Six wants to go down and jumps in and presses first floor. He's going home. Comes down. Lift door
It's
opens. I like
nice.
that lift.
The doors open
Very good.
and close.
Very nice. This is real.
So that's running on. So that's running. What's the fourth on this one here? It's the R3, is it? Or just having a look at that. Are you there, Pablo?
R3, yes. Pablo, estás ahí en la reunión. We can't
It's a
hear
very
you.
simple implementation.
Yeah.
I
So
internally is a state machine.
So 200 lines as well, huh?
doing this for a moment now before I want to go back to the screen here. Let me go set up so I can see what's going on. I should really have done that a bit earlier. And I get that, stop that. Okay. Here we go. So well, you know, how do you find this challenge? Sorry. All right. My audio coming through is it all? What's next?
Peter, can you hear me? You have problems with your audio. We can't hear you.
I hear you, Peter.
Then we have also George Orais from Japan. This is a new member, and we would like to see George. Hello, George. Are you there?
Yeah, hello, Peter Ford. I'm here.
Nice to meet you, George. And you have also a submission. Do you have a video to show the group?
Yeah, I send a video and I can also share my screen.
Yes, please do, because Peter Jakacki is in problems now with his connection.
Okay. So I shared my screen. Can you see my screen?
Perfect, George.
Yeah, hello everyone. So yeah, for my entry, it's in ColorForth. As of the moment, it's not finished yet, but most of the components are ready. So yeah, first I can load some people on the floor, so we can enter which floor they want to go. So like second floor, third floor, and fourth floor, and this will be from the first floor. So, and then the ward will be filled. So yeah, this is loading the persons for the floor. Then I can also turn on the up button in the first floor, which is first floor, then up. And then we can also open the door by open, and then can also turn on which buttons, like button 2 on and button 3 on and button 4 on. And then we can also close the door and also go up or go down. So yeah, I think that's yeah, most of it. And yeah, we can feel also people from other floors like going down third or first third, sorry, a third and first floor, from fifth floor. Oh, sorry, I think I missed. But yeah, then we can also the fifth floor, press the down. So yeah, I think yeah, as of the moment, that's what I have finished. So yeah, I will work on the logics on the second part of this challenge.
Fantastic, amazing. Let me ask you a question. How long are you coding in Forth? Is this your first try at Forth, or are you a long time?
Actually, it's my first time. I'm still new with Forth.
How long?
Since last month.
Wow, that's amazing.
So what make you pick ColorForth?
Because I had bought the green array evaluation kit, and
Wow.
and I was learning ArrayForth of both ColorForth and SaneForth versions. So, but yeah, I selected ColorForth because it's very interesting and unique. So yeah, that's the
Yes, it is. Yeah. Thanks.
yes. So
Wow, great.
yeah, and so the code, I think I can also show the code. So this is the code, and this is the main block, and here are the variables and user interface and some helper functions, and these are the draw functions, just drawing the boxes. And yeah, we can see some documentation. So yeah, this as of the moment, this is all the codes. For
Nice.
so yeah, that's all I can share for the moment.
I am very happy to see a ColorForth submission.
Sure.
Thank you. Okay. So yeah.
And also probably in the future, in next month or in 2 months, you can show it in GA 144.
Yeah, I will try. and still, yeah, I'm also aiming to run Etherforth on the board if possible and see how it goes. So yeah, thank you. So I think yeah, I think that's all.
Fantastic, fantastic. And let us see if Peter Jakacki audio is back. If not, I will show you my submission. It's a physical model of the elevator, and I have a live demo and I have slides. I will share my screen. And this is the Forth 2020 elevator challenge, gentlemen. Fantastic idea of Peter Jakacki, and I wanted to make something with the things I have at home. And I created a very simple elevator, and this can be used by father and son. For example, you can build this to teach your son or your anyone you know in your family who is learning electronics, etc., or is a maker, how to build something out of cardboard, a wooden box here, And of course, the ESP32 chip, because this is the one we have with the Arduino support and is excellent, documented, etc. So I did the parts. You will need some push buttons, a display, SPI display, if you want to show the floors, the chip here, ESP32, and you will need, of course, your computer, cables, and a breadboard, and you can use an USB charger for power supply. I used two reflective sensors, one on top and the other as encoder, and it will cost you from $30 to $50 approximately to build something like that. And I wrote here, nothing if you are a maker. That was my case. I had all these parts available, so I did not spend anything. The setup of the breadboard and cabling. So you see here the power supply quartz. And this is the winch. You need to make a winch on top of the box. Here you see the sensor and a reflective aluminum tape or aluminum paper. I placed two of them 180 degrees apart. And this is a lid, a plastic lid of medicine or something you have at home that will drive the nylon cord or nylon line. And I used a motor here, a servo motor with a direct drive. This means it's a hack of a servo motor. You can find this on the internet, how to hack a servo motor to get it always spinning in one or the other direction. And then you have, well, here the parts again, and mounted everything together. The LED matrix in action, the SPI LED matrix, and the push buttons. And now I can show you this running. So here you see my camera, and here you see the code. And let me see the interface here. I have always running this interface, and it's telling me it's stopped. This is a multitasking application. So I have, you see, I am working here. I have a working force, but it's receiving all the time over the USB, the message stopped because the elevator is stopped. So when I press the button here, 0, 1, 2, etc., I have here the floors. The elevator will run, for example, to the 6th floor here. And you will see on the display, the numbers are changing. And you see it's a multitasker application, so I can ask for help and see the words I have for this elevator. This is Fred. This is Peter Jakacki's icon, and he asked me if to put a small Lego or Playmobil into the elevator, and I found his icon. I hope he likes to see himself traveling on the elevator. It's number 5, and now we arrived, number 6. So it stopped, and you see the message changed here. It's showing people can go up and down from the elevator. Now we travel again to floor number 0 here. The speed is variable, so I can change the speed of the elevator. You see I have Oh, it's not on the help. I need to update my help. I can compile at the same time. So let's update my help. Look at this. Compiling a new word, and the elevator is running. It stopped. It stopped, and it goes back. It shows me the GPIO 34, and I can make another help. Help here. Oh, what's happening? Oh, my screen is. This thing here is complicating my life. My help, for example, the spy is to talk to the init of the display. The print a number, for example, I can print a number 4 on the display and 3 on the display, etc. I can show all inputs to the back. Here are my inputs. And I can also travel without stopping the elevator, traveling to another floor. So I can go up from here, and I can at any time stop the elevator. I am stopping the elevator, and now I travel back, all time back. So these are the things I like in Forth, because you can debug your application while you work. You can work with a machine, and you can, for example, show inputs, and I can see the code of this word, and I can see how up is done. It's a servo word. I am working real time with this, and the code is very small. My application is 120 lines. These 300 lines are because of these phones. I need the phones for the spy, for the display. So it became a long program only because of this part of this spy display. It has 180 lines. If I take these 180 lines from the full development, you see I am at 150 lines, 140 lines. And what we show here, and we can learn here, are interrupts, how to work with interrupts. I read the pin 4, which is an encoder. It tells the position of the lift. And I have a servo motor control here, which is a PWM. And here is the speed of my system. And we have also inputs. We have GPIOs used for inputs, which are read on a multitasking scanner, which gives all the time feedback to the program and controls the Forth interpreter. So there is no program running here. Basically, this is what I like from Forth. There is no program running. It's just sensors actuating automatically. I press again. You see here, I am working with Forth. I can see my block files, for example. I can edit and change programs. At the same time, I can press a button and send the sky to the second floor, and it's working in the background. So everything is working in the background while I type here. And I can work and charge other programs as well. So this is the power of force that many people don't know. And this is what we want to show. Simplicity, and something interesting to build. And I think it's a great learning tool and also interesting for makers. This is my presentation, finished.
Peter, you are truly Mr. Wizard. That was fantastic. I loved it.
I learned a lot with Don Golding because he was my inspiration, and Brad Nelson and Dr. King. They did this wonderful maker fair with the ESP32, and then I came and saw these videos on the SBFIC channel, and I said to myself, this is wonderful what they are doing. I am a maker from Brazil. I will do this, follow these guys.
Peter,
Where
I
is-
didn't see a counterweight on your lift car.
Sorry?
Did you have a counterweight on your lift car?
No, because this is very simple, Jason, and it can be added. I added in the beginning a counter lift, but then I took it. It was not necessary because this is a card box, and it's so it has no weight, almost no weight.
Peter, I think the question was a joke.
But I implemented in the beginning. I added a second nylon and made a counter lift because I think it's necessary. But the servo was so powerful; it made any difference.
Peter, this is exactly what we need to promote Forth. You were so big on the maker boards. I hope you're going to put this on all the maker boards. And also, I'm wondering, is there some sort of tech ed board for teachers, especially in junior high and high school? If we could find a board that talks to teachers and put things like what you did on there, with maybe a...
Don, this is interesting because the breadboard, the only thing we have in this breadboard is one ESP32 chip, nothing else.
Right.
The rest are cables to the sensors and one to the motor. It's only 3 cables to the servo motor, and it's inexpensive and it's a great learning tool.
I totally agree.
Yes, everyone can build this and we'll have a lot of fun. I recommend I used a wooden box I had, but you can make a wooden box. I will make the plans of this. I will elaborate as a learning kit. And I hope many people follow us.
I think it's absolutely fantastic. I just love it.
And it can be done everything from cardbox. I saw other people doing this with cardbox, also the skeleton of the building, and it's a great project for a weekend. This can be built in Saturday and Sunday, father and son.
Yeah, I like the
Very nice.
multitasking too. When I design,
we can add in future a Core 1 running the elevator, a GA 144, and we can move on to other levels of complexity.
yeah, absolutely. I like the way that you use the multitasker. I implemented a different version of multitasker. It's foreground, background. Or maybe you can explain how the ESP multitasker works if we have a moment. If not, we could wait till the fourth cafe. is it time slice or is it foreground background sort of thing?
Brad is in the meeting, no, and he can, of course, yes, in the first cafe and
Okay.
Probably good.
it's a time slice, basically.
Yeah.
Yeah.
How's my audio going now, Peter?
Yeah,
Is that
yeah,
any-
it's there. Yeah.
much better. Okay, I swapped over computers. I have too much running on the other one, and I really need to get Zoom running up on here. Well done, Peter. I mean, you know, you're the only one who actually built a physical model. I mean, I'd really love to find a building somewhere which was just newly commissioned, well, being commissioned. You know, I've been in them before where I've worked on things, and it's like get into the lift controls and take over, write it in Forth. Yeah, but that would be fun. But yeah, no, that was really good. And yeah, you know, good to see our little Lego man in there. And Fred is my avatar. Reason I had Fred as my avatar in the Parallax forums was that I happen to have an ANSI graphic for Fred. And I thought, well, if I use this as the avatar, then I can also throw it up on the terminal screen as well, because in ANSI graphics. But the ANSI graphics these days on a lot of terminals, they don't support the same character sets, etc. There it is, eh? Oh, there's
Peter, do you know that Fred in Spanish is Pedro? It's Peter.
Yeah, same, eh? Fred, huh? Well, there you go. Yeah.
And this is why I have one with me, because I am also Peter, you see? Can be either of us running inside the machine.
Yeah. And so, when you think of Freddie Flintstone, he manages to, they don't need a lot of high technology, but I mean, they do things very simply, yes, we don't quite do it like that, of course. But I'll just I'm going to show you mine for the moment. Just go very quickly through that one. I haven't really changed it because there's a few bugs in there. I know where they are. I just haven't gotten back to it all week. But what I'll do is I'll just share my screen here and just make sure that this comes up okay. Sharing a screen.
Yeah.
Sharing. Which screen am I going to share? It's going to be, which screen? Is it the whole desktop, is it? What's sharing at the moment?
Yes, we see the browser to the left and the editor to the right.
Oh, okay. All right. So let's make that a bit easier. Where's my share stuff? It must have jumped into that automatically. So I'm just going to just do stop that share and change the share controls on this so that you can. Well, in fact, actually, I'll tell you what. I'll just leave it. I'll leave it like that. I'll bring up the this over here. You can see the terminal over there, and then you can see the. I'll just bring that across a little bit. Can you see the terminal on the left?
Yep.
Terminal screen, and then the code on the right hand side. Well, that's good. We'll leave it at that. And so what I've got is this code in here, which is the lift, which is nice and easy. I just tell this just to set up everything else and so on the variables and tell it to operate the lift. Operate is a very simple loop. I noticed Francois had a 2-second loop, which is what I had initially, but I want to have the buttons being checked more regularly. So in there, I just have a little dwell time depending upon the what I'm doing, etc. In actual fact, that's the speed that I'm operating at, really. So I should change the name of that. And then basically I just go through and just keep on checking the buttons while I'm waiting in between. And then what I'm doing in the code here is I show this. This is what this happens up here. Let's see if we can quit out of that. Quit. There we go. And so clear the screen, show. That's all show does. Okay. So at the moment, it's just set up with 6 levels. So I'll tell the lift to operate again. Operating. I have extra controls built in there. You probably see the buttons over here. When I check the buttons, what we're doing is that we are looking at going up and down. So I can press up and down. When I press a digit, when I press a digit down here, can you see this line here? I basically fetch that switch that I've saved in here and convert that to and add it to a number. So I'm just building up a digit. So for instance, back here I go 1, 2, 3, 4. Does nothing. And back down here I can clear it again. So I'll clear that this time I'm going to say 12, and then hit the hash key, which is in this case setting up to the number of floors I want to set up in there. So I can dynamically resize this to really test out the logic and be able to have multiple floors being requested at the same time, as you would expect when you have lots of floors. People are pressing the buttons as it's going up and so on. So down here I have 12 floors, and of course someone on the bottom floor is on 1 is hitting the up button, and there's people there, and so the lift opens up, screen there, and what do you expect to happen? The door closes. So obviously it doesn't go that fast, but I don't want it to go all that slow either. And so they get in the lift and they say, okay, well, I'm going up to the 10th floor. So 10, go. G for go. We can see the go in here, what happens, or the carriage turn key. Gets up there, opens up, lets them out. This is fine. People on the 8th floor want to go down now. Oops, I should put it back here. 8th floor want to go down. And while they're going down, there's also people on the 6th floor that want to go down. And now I've got a little bug, which that's actually working there. All right, okay. And in there, they've hopped in. No one's pressed a button to say what floor they want to go to yet. Even the ones from the 8th floor, they're a bit slow. I think they're on their device here at the moment. So what happens now is that we go to the 1st floor, of course, is where we would normally go. And in the meantime, of course, there's a request for going down from 8, as well as a request. Oops. I don't know if this will work, but I'm going to try 11 down. Would that? Should I allow that? Well, I'm not sure, but I'm going to look at that when I have more time. And the thing is that we can have multiple requests going down, 9 down and 6 down and 4 up. And so we can see that it should be going down there, ignore that, and go to 1. It should ignore 4. I have a little bug there. That's okay. As you can see, I've got a little bug there that shouldn't be doing that. So, and I know exactly where that is because it's in my little compute loop where I don't exit the compute loop. I just go on to checking the other conditions where I'm going up and down, checking the ups and downs, etc. So it's fairly easy to fix, just haven't had time to do that. So that's basically what it does. I can change some other things in there, the speed, etc. I can tell it to go a lot faster, perhaps. Let's see what happens when we tell it to go up to 12th floor. So we go up a bit faster, back down to 1, and up and down going like that. And of course, I can slow it down just to see exactly what it's doing when it does it. I'm not trying to make this complicated. I don't need to know the number of people that are in there. I don't need a counterweight, although now I'm thinking about that. And so, yeah, it's good just to simulate things, good to even simulate people in there. But the reality is that even though there's a load capacity on most cars, that basically there's only so many people go in there, and other people have a look and go, oh, I don't want to go in there with those smelly people. Yeah, I'm not too fussed about that. I just want to look at the logic going up and down. Looking through my code over here is pretty much in my compute loop. I check the requests. Are there any requests? No, I do a quick, if it's 0, I just exit. So 0 exit. I don't know if there's any standard fourth word for that. I think there's a question mark exit for true, but I use a 0 exit. Otherwise, I will check the floor, what floor I'm on, to make sure that everything's okay. And then I decide whether I need to go to any other floors, etc. I can't remember half the stuff I've done in here. It was a couple of weeks ago, really. And then I check all the ups and downs. What do I need to do? What happens is when I look at that code, I might look at it a week later, and I'll think, I can make that one nice, neat little function. First things first, I make it work. So I just get it functional, and then I start to see it and start to see the pattern to it. And I can do this totally differently next time, but this is just really my first attempt at it. And so this is the code here, pretty much this section here, which has the different variables. I like to define what type of variables they are. Are they byte, many bytes, a long, a 32-bit long, etc. In this case, I only single byte variables, etc. But I also happen to have down here, depending upon the number of floors that are set. In fact, the maximum number of floors are set to 64. And then I set up the ups and downs by count the number of buttons that they press for ups and downs and the number of people that want to go to, say, floor 6. A few people might press floor 6, and I just like to be able to see it. But mostly I just check that for a flag, the non-zero flag in this version here. And so everything's nice and simple. There's a lot of one-liners, as you can see there. And notice I haven't put a lot of comments, not even stack comments at the moment. I just get it functional first. But question mark always returns a flag. Either way, I'm going up or I'm going down. That's all I want to know, or I'm doing nothing. I'm just idle at the moment. And also I have controls in here for parking it, telling it to go up and down. And it's just really simply setting a value there in that lift control variable. Nice and easy, really. The basic part of it, I did in no time. Most of it was really just making drawing at first. As you can see, this is the part here. I should separate this a little bit. Here you can see where I've got the part that says show. Can you see that okay? And pretty much off cursor, so I don't have a cursor jumping around the screen on a Nancy terminal, and tell it to go home and in bold, etc. Reverse how I print the title, and that's the title, Lift Simulator. And therefore, what else have I got? Oh, no, I've messed that up. Messed that up there. Okay. An easy way out of that. But I've went and reset it all now. Okay. That's right. We'll come back to that. Yes, there we are. Better. All right. All right. I know what's going on. I've got it's my serial port on this device here. It's got a little bug in it. I wrote some firmware for the USB serial chip, and I have one little bug in there. I've got to get rid of it. Let's see if we can run that again. Let's put that in again. I'll have to paste that one in. And then just having a look at the code here, as you can see, there was quite a bit of code which just basically says, well, let's just format all this, make it look pretty. So most of the code is actually to make it look pretty, even on ANSI graphics. Imagine what happens when I go to my VGA graphics, which I have, or the HDMI graphics, which I have running on the same chip, but on a larger screen. So what I want to do next time is have sprites, have real elevator doors opening and closing, all those real buttons and everything else, and draw them all over there and have it really animate it very well. This is what I think I find with, I hope I'm not talking too much, but if we have this much code, then this much of it is really the whole human interface, what we see. The actual logic part of it is this tiny part. And so this is what I found in here, is there's not really that much code that's actually to do with the actual logic and running of it. And it's very easy to debug, as Peter said. You know, we can just come in here and just use any part of that there, etc. I think if I check this now, I'll go back to 12 floors, bring it back up there. And as I said, I've got controls in there that allow me to even exit out of there. Control C back out of the loop. I'm not quite sure why what wants Control Q, I think, Control Q. And to quit out of the loop, I can go in there and just check any particular part of it, check the variables, debug and so on. So that's what I liked about that. And come back to here. All right. So next, who do we have here now? I'm just going to just check some of these ones here. I'll have to pick, okay, we had James. Are you there, James, at all? James Norris?
I'm here.
All right. Okay. Would you? I'm going to just bring up your code here, your video, and perhaps if we play that video there, you can comment on that as we go through, and also what you like about it. So I'm going to just share that in just a moment now. unless you wanted to share that yourself and handle that from your end.
My video's on the
would
Mac
like-
side and I'm on the,
Yep.
in order to Zoom might be on Windows. So
Okay, so you want me to share this or the video?
yes,
or-
please.
Oh, okay, all right.
I
okay.
do have the elevator on my Windows side if you need that, but
That's okay, yeah. So what we'll just do is, there you go, yeah. Jim, all right, so I'll just share this one here now.
black screen. Oh, I don't see anything. Oh, I need to do that.
Oh, that probably didn't work. So maybe you try again, Peter. Aha, Peter's video is frozen on my side as well.
Yeah, Peter's frozen here as well.
I don't see anything on black screen of that.
Mhm.
James, really happy to see you in the meeting.
And Peter's gone.
Okay, I can just share
Mhm.
this. How do you share a window on this thing?
So there's a green screen share at the bottom of the menu.
And I can pick a window.
Yeah.
Where did it go? I'll just do the whole screen.
Yep.
Okay. Can you guys see that, my screen?
That works, yeah.
Yes, perfect.
And here's the elevator simulator. It's running as a CGI application. We have it on Mac. I just brought it over to Windows. I only needed to change this URL to get it to work on Windows. So you can pick any number of floors. I covered all the cases and I did that first. So I made this file first and I tested it after I sent him the document. So this is what the cases are and what it covers. I sent him that. Then I wrote the code that did it. Then I tested the code, and so it covers the, it's above and going up, below going down, below going up going down, and then I made the floors the same weight as what you would want it to do. So if it's going up, then you would obviously, and some push the floor button would take priority and be the same as, an up floor when you're going up. So there's those 4 cases. Then there's the 3 directions. I covered all the cases for that. So you've got like 12 different possibilities. I tested all of them. So if you watch it, it'll do it. Go to the cases in the correct order. And that's basically it. For fun, Peter wanted some Easter eggs. So for fun, if you put it on a floor that's too high, get the little emoji there. Put a bunny in the elevator if you want. Put it back down. And that's it. Everything works. I didn't find any bugs. It doesn't show the elevator going from floor to floor. And this is a CGI application and running in Forth. So if you want to do something like PHP and you're like, why don't they have a Forth? Well, this is PHP with error checking. And that's pretty much it.
Very good. Wonderful.
And I can't stay after work today, so I've got to get going. Does anyone have any questions?
Well, do you want to continue on the elevator, or is it
The only
what
thing
you
we
have?
do is make
or-
it go from floor to floor and open the doors. Otherwise, it's
Yeah.
doing all the stuff a normal elevator would do, probably correctly.
Mhm.
You have the people coming in and out. I was originally had people coming in and out. Peter's like, no, don't go to that level of complexity. Just make it go from floor to floor. So, which is good because then I probably wouldn't have finished had the people going in and out.
This is a great opportunity to see all the members of the group showing their forth. So we are very, very happy, Jim, you are here. And Matteo, do you have also a presentation, a short presentation?
Okay, I can show a few seconds. Let me start with my Ford. I didn't prepare anything.
Yes, please.
1 second. I can share my screen. Where is it? Okay, I can show the emulator. Forgive me, but I didn't prepare anything. Loader. Okay. Can you see something?
Perfect.
Yeah, yeah.
Okay, this is my Ford. It's just really a toy, but it is fine to see what it does. Oh, okay, I start. Okay, I block it. I can press brake. If you know what a ZX Spectrum is, Sinclair ZX Spectrum is, you know that it's very limited machine, but it has a Z80 CPU that can do very limited things. What I did is this. I code. Okay, the code itself is another Windows I show later, but from inside the emulator, I can import load simply. I can simply go one load, and this way I can include the Forth source. The Spectrum is very slow. I'm sorry. I'm fascinated every time I see your Forth. I'm very envious because my Forth is very slow. Okay, run. Okay, this is the emulator. I implemented the mouse interface, so I can simply click. You can hear click or click. I can queue up a few click if I have fast enough. So it should stop at every floor. Okay, this is what I did. It's very simple, but I can. Okay, there is no floor button. I just coded the cabinet buttons, and the mouse simply the position, the vertical position of the mouse is decoded in number. So the cabinet starts and stops. I also give a small delay because it has to close the door and start the engines. That's all. Okay. To see the code, let me show the code because this is the challenge. The code is this Windows here on the video. Okay. Okay. I know that this. Okay. I followed the instruction and I coded from the bottom the run that simply reset the mouse position. Then it built up a loop that check the mouse, display a frame in the video, wait some delta t, and checks for the brake button in the machine. Okay, display. Display is just a display what you say. The computer is very simple. It is very 10 line long. I don't think more. I just thought in my mind, what must do a lift? If the door, halt the engine if the door opens, open the door if the engine halts, and if the engine is in action, engine is a variable that contains the speed of the engine itself. So it simply add some value to the current flow of the floor of the cabinet. I used in my mind, I use a trick because current floor is an integer, but is divided by 256. So in my simple 16-bit arithmetics, I can use the high byte to show the real floor, and the lower part to make up some delay, so the engine can add a fraction of the floor at a time. And okay, going back to the dashboard. Okay, the computer is quite simple. If we add it recognizes that it has the correct floor, it can do some action, and all the logic is in this decrease timeout. I mean, every time I click the mouse and is an action recognized by the engine, then it put some delay on the correct timeout. Then if the cabinet, the lift, it at rest, it decrease the timeout. And when a timeout goes to 0, it starts the engine. So timeout is somewhere up. Timeout. This one. Decrease timeout if the timeout expires, it requests the floor, and that's all. So the logic is, I always kept in mind to have a real hardware underneath my software. So even if I didn't build up anything hardware, real hardware, I always thought that in some point, point of the source, I thought this must be a sensor, and this must be a timeout. So I put a value to unrequested floor. I put a value on requested floor, and the machine must act conveniently. Well, that's all. I don't think there is much more.
Excellent.
Thank you very
Fantastic.
much.
Next one is Vladimir.
It's not complete. Obviously, it's not complete. I told to Peter that I didn't code the floor boot buttons. But I think that is quite easy to complete this.
Yeah, well, I really like that you say, I imagine having a real hardware, which opens up the possibility of the next level of the challenge, so that we exchange the programs and we try to let it run on Peter's model, or if other models come up, run other programs that control the elevator in different scenarios.
Yes,
I think by this we will learn a lot.
Yes, from the beginning, I thought that there was an engine, and an engine must be a positive number. The variable that contains the speed of the engine must be positive or negative. So in each loop, I always check if engine is in non-zero, it must change the lift position, and so on. And when the lift is in the correct position, it does. So every time it loops in the inner loops, when it checks if the correct floor is it arrived, it should be a sensor in the correct position.
Perfect. Ulrich, do you think we should continue with the next speakers, or we should show Vladimir, who has a birthday today, Vladimir Gumenuk?
Yeah, well, why not Vladimir? That's fine.
or he can show us in the next meeting also.
Do you hear me?
Yes, Vladimir.
Yeah,
Hello.
yeah,
Do you see me?
yeah.
How to share my screen?
Fantastic. Happy birthday.
Thank you. How to share my screen?
At the bottom, there's icons, and there's a green icon called screen
see.
sharing. Mhm.
Interesting.
Yep,
So here the application.
Midnight Commander or something.
And no, it's for Windows.
Yeah, anyway.
This is a program. So basically I implemented exactly in the same way as it was suggested by specification. So the functional buttons on keyboard acts like buttons inside the cabin. So if you, let's say, press 2, 3, 4, 5, and the lift will go to the floors. So you can also, let's say, to increase a bit speed to make it go faster. And also the application can operate in the playback mode. And for this purpose, I created the scenario file. You see it. So it contains very simple commands. So now to switch the mode, I can press P. And now it starts to execute the script. Let's make it a bit faster. And as far as I understand, we implement just a very simple logic without any smart logic. So when the button is active, doesn't matter which floor, and the lift still hasn't passed this floor, it should stop, as you see. It's very quick, and at the end, as I have already mentioned in the video I provided on Facebook, I decided to implement special rewind command. So I found it useful to loop the script. So it just starts to execute the script from the beginning. And it actually helped me to debug, find the bugs in the code. So now I guess it starts to execute the script from the beginning here. And to exit, just escape, and the application will be closed. Probably let's take a look quickly on the code. So it is on Windows, it's Windows application. I with a lot of commands. So here you see the importing of Windows API from DLL, and the definition, the wrapping, a lot of constants, basically the mode is interactive playback, and functions to words to switch between the modes, the code to determine the bottom, where the lift is on which floor. And here I define all the buttons. And as I was not able to define the mock-up of the building in pseudographics, so I decided to define it with key characters, and on the fly, when I render it, I change it to nice pseudographics. This stuff just to print the mock-up. Here, all buttons and doors are compiled as arrays, and I decided to add a dummy button for 9th and 1st floor. This is because it makes the indexed access much easier without
doing any additional checks. These two buttons, two dummy buttons for 9 and the first floor will never be active and visible. So we are still rendering, and the logic of user input. To what I saw, that almost every forter implemented almost exactly the same structure. So I have very similar code as Peter showed us. This is the definitions for handling elevator logic. I guess everything is very simple. For this challenge, I try to avoid any crazy stuff like object-oriented force, even local variables. So just pure, very simple force, as it, I guess, could be or should be. Here the code to evaluate script line. So in playback mode, it reads the file while line by line and executes evaluate words. So, and here the definition of that commands. So basically, and this is the very simple. The final word run just initialize ticks, milliseconds, and enters the loop. Please note that this force can run in case can compile in case sensitive mode. So this is a loop with smaller letters. Is not the same as a loop with uppercase. So that's basically all.
Nice, thank you very much.
Nice.
Excuse me, may I ask a question?
Yeah, sure.
I saw all this code, and when we look at code, we always see things sequentially. I'd like to know how you created this. How did you start, and how did it evolve to end up with a solution? More in human words than in code.
Basic. I started with this. And when I have the model, it doesn't matter that it just coordinates on screen. And after this, I had exact coordinates and positions. And after this, it was very easy to construct this final solution to operate.
So from what I see, you started with the simulation. Like it's the floor you're showing us.
Yes, I would say with drawing.
The drawing.
Right.
And from there, you created words to be able to modify things in that drawing?
Yes. Well, honestly speaking, I do not remember exact path of my solution, but after this, I created the words to communicate with the keyboard, to actually handle the keyboard input. And then I started with this. So this is the final part. It actually operates. What it does, it takes this. I have 3 variables that controls the keyboard. So this is a requested floor, requested direction up or down. And the button in cabin. This word apply. It just transfers the user input to the elevator state, because the state of the elevator consists of, yeah. So now we understand that for this exact simulation, the total state consists of 34 items. It's all buttons and all doors. And later, here in the logic, it's basically runs. It processes the state. So how to say, the elevator should serve the requests. And once the motion has started up or down, it doesn't matter. It just should go up, let's say, until all requests will be served. And the same when it would go down. Did I answer a question?
Excellent, excellent, Vladimir. Thank you very much.
Thanks, Vladimir.
Great.
Will we have a text version of this code?
Now we need to move
I would
on,
like to
Christian.
use it to.
Yes, but now we need to move on with the presentation of other people.
Okay.
Thank you, Christian, for asking. And then Ulrich, are you in the meeting?
Yeah.
Should we continue with the presentations?
Well, it's actually what I want to show is maybe interesting, but the lift challenge puts the bar so high. It's so interesting to see this. So I really feel something like, well, it's not interesting what I want to show.
Of course not.
So, but we can continue with the lift challenge things. Sure.
From my point of view, I don't know anyone else who submitted solutions for Peter Jakacki, but if anyone, Travis was another one with SpectrumForth. Peter is not more in the meeting. He lost the connection.
Mm-hmm.
So we are free. Either if Travis wants to show us something, or if you, Ulrich, you want to continue with your presentation.
Sure. Yeah, that's what we can do. I think the lift challenge will keep with us, will stay with us. To be honest, I did some simulation stuff with a lift with only a limited amount of time available. So that's not enough to show, but I will keep on working on it. And then maybe next month or in the 2 months time frame, we can show, and maybe we have this as a repeating point in our meeting, maybe not as extensive as today, but in a shorter thing, so that one or the other guy will just show this is my solution to it, and maybe we collect the solutions at some place. I don't know. We can see. Yeah,
I agree, Ulrich, because probably we can find makers, as Don well said. I can share, and I will share, a full project inside maker groups, and we can make a lot of people awake to force. So probably, yes.
Yeah. So that's nice. Okay. Well, that really was amazing. Seeing all the different approaches, how to do it, working on the same project and the same problem, and the different attempts to solve this. So really great, and especially having a model, seeing a model that actually works this, and Fred Flintstone. Yeah, so okay, let me share my screen, and then I would like to kidnap you to some earlier times. I would like to talk about VolksForth in the browser. I don't know whether you're aware of what VolksForth actually is. It's a 16-bit force system for DOS that we developed in the 1980s. It's in some archives, and if you are a guy that wants to do retro computing, maybe you have DOSBox running already and play old DOS games or whatever. But what I want to show you now is that it's no longer necessary to install any software. You can just go ahead and run VolksForth directly in the browser, make your experiments and try it out, look at the source code and so on. And after the short demonstration, I will a little bit explain how it works, because it seems to be, well, quite amazing. So here we have a browser, and here is a URL. I can pick the URL and I can paste it in the chat. Let me see if I can do that. No, I can't, because the chat right now is not available, but it's, let me see, can I do this? There's the chat. And I can paste it in the chat. So it's all visible controls of Zoom here. But you can see it, and you can do the same thing that I did, or that I'm doing right now. I just load that page and it loads some stuff, and here we go. There's VolksForth in the browser, and you can just go ahead and work with it. Try 3, 4, and where's the plus here? Dot. Yeah, it actually works. And you can see C words. Include c.scr.
Switch your display.
C words. Can you see my screen?
Only the intro page. VolksForth.
Only the intro page. Okay. Then let's see. That's interesting. Aha, right. Okay, let's see. Then I stop this and right. Here we go. And
Perfect.
then
Perfect.
what we do is I just reload the page and I start over. Yeah, I reload the page, and what we can do, so 3, 4 plus dot map dot. That works. I can see words. No, C is not available. I can include c.scr, which is the decompiler. Then I can see words decompiled from what is in the dictionary. If I do words, we see the words that are defined in the dictionary. We can look at the source code. We can view list, or we can say view words. To have a look at this, well, it's some alias, but anyway, let's see, we say view dupe, for example, and you get the source code of dupe, which is assembly. It's a 16-bit indirect threaded code system for the 8086 that runs right in your browser. You can launch the editor, which is started with, or we can just say ED at this point in time. And you put in your initials, and now with page up and page down, you can just go ahead and have a look. Let's see, fix dupe maybe, then we jump to the appropriate source code, and you can just browse around, page up, page down. You can hit F1 to get some German explanation. That's something that we are working on with the revival group to translate this to English for make it more accessible. But you see that on the timestamp, it's from 1986. And yeah, so, and you can just work around with it. It has a multitasker. It has lots of nice goodies to look at in the source code. And well, underneath what you have, if you just say buy, you really get a PC, a DOS computer that you can run. So we were just running the VolksForth program. There it is, VolksForth.com. Yeah, and you can rerun it like this. but it's actually a PC that you can use. And you are, maybe you recognize there's also the meta compiler, meta.scr. And what I can do is I can see that we can run the meta compiler. So .scr first, use meta.scr one load. So the first thing that we need to do is actually create the meta.com program, and that's what I just did. And then what you can do is use kernel .scr. Yeah, there it is. And then you just say one load, and here we go. The meta compiler runs. It all runs very fast indeed in the browser. So that created a new fresh image called forth.com, and you can run it, and you can use VolksForth.sys one load, and here we go. It loads all the extension, and you have the VolksForth system. Yep, and it just starts the same, but let's see if we go here and go to the beginning. There's the boot message somewhere. So as a as an exercise, you can just change the boot message a little bit, do the meta compilation, and create your own forth system there. Yeah, so that's what it is. And the nice thing about this is, if I reload this again, I need to do some changes. So to show you, yeah, let's see. We go here, and yeah, maybe I just change this to ABC. And yeah, whoop. And now if I reload the page, go to a fresh copy, it's actually, it makes it persistent. So if I say fixdupe and we go back to the boot prompt, there, it's still there. And how this works, so it actually is a PC that runs in your browser, but it has persistent file system. So if we look at the kernel.scr and the date, yeah, you see they are all changed right now, and kernel.scr is actually changed just a minute ago. So it has a persistent file system that runs in your browser. After a while, it will be flushed, but you can make changes to the file system and make it persistent. So much these things. And I would like to show you how this all works. So normally you have the com file, VolksForth.com, and in the old days you had a floppy disk, and you booted the DOS system, and it had this file system. And you booted it had the command line that we saw earlier. And then you issued VolksForth, and it started up the system. You can use it. And so you had your own computer that ran directly DOS, and on top of that, you could use VolksForth. And well, today, DOS is not the primary operating system that we use, so we have to have some kind of emulation. And there is this nice program called DOSBox that is an emulator for a DOS PC. It's written in C, and it uses an abstraction library to make all the nice games graphics that would be interesting. And then you use your desktop operating system, and you install DOSBox. Inside DOSBox, you can run DOS, and then you can run VolksForth on top of it. And maybe you have some extensions that are interesting, and they will come in right now. So then some clever guys said, well, having all these nice C programs, and we need to port them, that's nice, but wouldn't it be a good idea to be able to use them in the browser. And that's where the people came in and they developed a C compiler that is called Emscripten. And Emscripten can take non-trivial C programs and compile them to JavaScript. And so it takes this C program and compiles it to JavaScript. And so if you use the DOSBox C program with SDL, you get a DOSBox that is written in JavaScript. And this can be run inside your browser because it's JavaScript. And then the SDL library will draw on the canvas in your browser window. And then you can use any modern operating system to run your browser. And inside that, you can run the DOSBox in JavaScript. And inside that, you can run DOS and so on. And by every system, I mean every system. You can use it also on an iPhone. With the drawback that you don't have a keyboard, so you can boot it up. And but if you have a Bluetooth keyboard, you can use it on the iPhone as well, if you want to. Yeah. Anyway, now how does this persistent thing work? There are some extensions that developers that ported DOSBox to JavaScript did, is they build a abstraction layer that maps DOS file system calls to browser local storage calls. So every browser that we use has something that is called local storage. That's a key value store that your browser, as long as you don't wipe it, allows programs to keep data in it. And so the DOS file system calls will actually be mapped to browser local storage calls, and your files will be available in this local storage. If you have access to developer tools on your browser, you can have a look, and you will find the file names along with the content of the data in your local storage. Because DOS programs tend to be very small from today's perspective, this all works very fine. So if you clear the browser local store, you get a fresh copy, but this is how the persistence is actually done. VolksForth modifies a file. It thinks it changes a DOS file system, but this will be actually mapped to the browser local store. The next time you load the page, it will read the file. It will address browser local store and find the modified value and present this to the system. So that's quite nice. I think this is a horrible stack, things piled on top of each other. That's not simple at all, but the effect is really amazing. So you can just go ahead, yeah, have this, and you can come back and use it. And if you want to try out something, how was this in VolksForth? Like, yeah, like some capabilities that yeah, VolksForth provides, and you just want to check how it was implemented at that time, then you can just go and use it in the browser. So currently we have just a white frame around this, which is not very helpful if you don't know the system. So that's something that we certainly want to extend, like some links to documentation. There's a handbook, and it's going to be translated into English, and there are some help pages in English already. And so that's what is going on in a group of German Forth developers that are happy to revive and preserve VolksForth, because it doesn't only run on a PC, as we see here. There's also a CP/M 8080 version. There's an Atari ST version. There's a C64 version for the Commodore. And all these systems look alike, so you can really port programs very easily from one implementation to the other. Yeah, so that is what I wanted to show you on the retro computing front. Maybe, yeah. So that's what we have. Okay, maybe there are some questions.
Excellent presentation, Ulrich. I love VolksForth. Ich liebe VolksForth. Und hopp, 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 hopp.
Yeah. We had scheduled a talk from Wolf Weigart, and what I did with VolksForth is actually not bound to VolksForth in any way. It could be done for other systems as well, and we have an experimental version of HolonForth running in the browser. And I would like to extend the working demo that we currently have so that we can easily show the interactive host target compilation that you can do with HolonForth. That is quite nice. From the beginning, it was a system that allowed to incrementally develop host target applications with an umbilical approach for embedded devices. So yeah, we will work on that, and maybe along with Wolf's talk that we will probably hear next month, we will see some demo on that as well. So the second thing I would like to show is the progress that we made on project ForthWorks, and now again comes the Zoom controls in my way because it's oh no, here we go. Let me see. Yeah, the Zoom controls are in my way, and so I would like to switch here to project ForthWorks. And again, we have a URL that I would like to share with you. Let's see. Here we are. I paste the link here. And so that's in the chat. And let me see that I can put the controls, the Zoom controls out of the way. I have a small screen here, so I have to see how this all works. So the project ForthWorks is a project that I'm doing with Willem Overkerk and Albert Niehoff and Jeroen Hoogstraat. The idea is while we have lots of Forth projects and ideas and algorithms, why can't we collect them and make a project where people can come, share their ideas, explain how they attack certain issues, and yeah, can just share their knowledge of how to approach different things. So you're looking at the welcome page. We were on GitHub for a long time, but it turned out that it's quite difficult to add things to a system that is hosted on GitHub, because you have to be a member of the group that works on this, and so that's not so easy. So we decided to ask the Forstgesellschaft whether they provide some space at the wiki of the Forstgesellschaft. And yeah, so that works, and I would like to present a little overview of what we have there. It's a wiki page, and everyone can go ahead and actually contribute to this, read this without any issues. But if you want to contribute, you would go and register with the web page, become a member of the wiki page. So no cost involved. And then you are able to edit, like I can, the appropriate parts. And that's the reason why we want to have a registration, so that not the spammers come in and mess up with the wiki page, because we think that once you register, you show some interest, and then you will probably well behave, so as I know. So here are some pages, a selection of ideas that we ordered by category. So like, how do you implement a buffer on array in Forth, or some circular buffer or bit array, how to address communication protocols, some algorithms like CRC or random number generators, system software, like assemblers and tools that you might want to use. And the idea is not to focus on a specific system and say, well, this only works with ABCForth on that computer. No, but to focus on the idea. So if you go there and let me see, we go here, SPI protocol, for example, you go there, you get an explanation of what the SPI protocol actually is. Yeah, and what you need to know without focus on any force system. And then there will be some pseudocode that is, explains how to access this. With SPI, you have two possibilities. Either you have a hardware that can do SPI, or you have just GPIO, then you would bit bang the appropriate protocol on the IO pin. And you get an idea of how this works with pseudocode that is not executable, but it's for you to understand. And then this follows with a collection of implementations for specific force systems. So on the top, you have the general part, the explanation of the idea. And at the bottom, you have one or more implementations of this. And if you want to contribute to this, you would just go and edit this. Yeah, maybe at this point in time here, you go and it's a wiki markup that you use, and you can just go and add another code and say, well, would do it in a different way, and would just go and edit this. Once you're registered, everyone can edit the things. You can't mix things up a lot. There's a revision history, and we can always go back to some earlier version. So even if by accident you delete something from someone else, that's not an issue. It's not gone forever. We will have it. Yeah, and so that's the overall general idea, to present the rationality behind these things. And whoops, let's see, ForceWiki Project ForceWorks, yeah, to explain the ideas and then give some implementations. And everyone can contribute with a version of its own force system, where you say, well, I'm using this great feature of my force system that no one else has. And this makes the program from 100 lines to 15 lines, and that's great. So everyone should think about using this great feature. That is very welcome. So we really want to know about that. Yeah. Or let's say if you have any comments, then you can just, I think that also works without registering. You can just go down and say, and write your comment and submit the comment. And that's the easiest way to contribute. You just go there and say, I have something for so-and-so, and that would be nice. And or if you find something's not working as expected, you would just go ahead and give us some information about these things. So let's see, random number generators, the same idea. Yeah, you learn about random number generators, you get pseudocode of what needs to be done, then more or less generic force version that should work on many force systems, and then some contributions. Yeah, and if you want to do some contribution, you go right down. Yeah, and yeah, we add another. Yeah, we add another contribution here. Like we copy this, and let's see, we go down and say here, yeah, my great version in ABCForth. Yeah, and then you can say choose. Yeah, let's maybe I switch to German keyboard. Yeah, it would be nice. U1. Yeah, and whatever you want to do there. And you can make a preview, go and see, well, where is it? Yeah, my great version of ABCForth. It's at the bottom of this section. And if I'm happy with that, yeah, I can just say save. And then it's available to be seen by everyone else. And yeah, if you decided to not have it anymore, you can just go ahead and remove it again. Yeah, say, well, not so good. I remove it. And then it's gone again. Yeah, so it's very easy to contribute to existing things. And the idea is really to be there and to maybe contribute to the existing things that we collected. Or if you want to do something on your own, that's also easy. You add a new page to the index, for example, and then well, yeah, you say you want to add another algorithm like this, and they say, well, let's copy and paste this. Like this, a string reversal algorithm. String reversal algorithm. Yeah, and then they say what? String reversal. String reversal. Yeah, once you did this and you save it, you see, oh, it's in red there, and it's a new page. And so we don't have this page up to then, but you can just go ahead, click on this, create this page, and now you will be guided through the structure of a new page. You get a template that describes what you could do. If you don't like it, you just remove it, but it gives you a good guideline, and it takes the dump algorithm as an example of what you could do, and to give a description of the idea, talk about the implementation, give a pseudocode, give some force implementation, what have you. And let's see, we do a preview here, and you see this would be a new page that you could fill out. I would advise to copy this, edit this locally, and later come back and then do this. But that's the third step. First is add something to the comments. Second is add some sections for the implementations. And adding new pages is that's actually the fourth thing that needs to be done if you want to contribute. But first, I would propose you browse the system, and you can do this very easily by clicking on the sitemap. And if you do that, then you get all the Project ForthWork pages, and you can just go ahead and see what is there. So what did we do? Some not so serious stuff, high-level implementation of do loops, for example. And have a look at that, for example, and see what's going on. So let me see what's up. I think that's mainly it. What I want to show as start. And if you have any questions, do not hesitate to contact me. So it's a nice repository of interesting things, but it's supposed to grow with your contribution. And if you want to just contact me or Willem Overkerk or Albert Niehoff or Jeroen, and then yeah, that's would be the nice thing. So that's this. All this is explained on the page. That's what I wanted to show to you. If you have any questions, please go ahead.
I do have a question, but it's not directly related to this.
Yeah.
Who is the secretary of forthev.de?
That's Carsten Strothmann.
Really?
Yeah.
Oh, okay. Because I emailed him about my subscription renewal, and he told me I didn't have to send any money, and I didn't see anything coming in the mail, so I'm a bit surprised. I'll get in touch with him again. Thank you.
Yeah. So it's actually Carsten. Mm-hmm.
I was going to have a question, but
sure.
I see you answer it. When I first look at your screen, I'm going, what? That's DOS code running on a file server? What crazy ISP allows you to do that?
Yeah.
And then later you explained that you used mscriptum to convert it to Java, which everybody ISP allows it, and bingo, off you go.
Yeah. So very, that's
very nice presentation, because I never thought of taking the code to DOS box and recompiling it to Java. And therefore totally usable to host software without having anything special about it.
Yeah. So, but yeah, as I said, it's quite complicated having this file system to local storage mapper.
But once you do it once, it's ready to go.
Yeah, that's right.
Very nice presentation, and I'd like to commend you on the second part where you group of people in Germany are setting up that wiki. It's a much needed item to gather source code that's usable from all over the world and have it available for anybody.
Yeah, we were discussing a lot, there is this web page called Rosetta Code, where there are algorithms, and then people contribute with their favorite programming language. And we thought, well, maybe that is nice, but with a more focus on explaining the idea and then contributing force implementation. So everyone can contribute with his idea of how this problem needs to be solved in a special system on different controllers with different force systems or whatever. But above all is the general explanation of the idea. So how do you do SPI bit banging?
And well, not only Rosetta Code doesn't explain a whole lot, but it's mostly mathematical algorithm.
Yeah.
That's basically what they have there. And your website is going into real world examples of how to do things.
Yeah.
Like you said, talk to an SPI port.
Yeah.
That's really handy. A lot of people have no clue how to do it.
Yeah, exactly. So so even if you have a small contribution, it can grow, and I think it's more the idea that it's collaborative. So no one has ownership on certain topics. So if you have just the code and say, well, I have this code lying around for a long time. It does this and this, and you can write a paragraph or two of how it does it. Then maybe others come in and say, well, that's interesting, and let's make this a topic on Project ForceWorks that we get a good explanation for everyone to participate in that and to learn and understand it.
Thank you.
Sure. Okay, yeah, so that's what I wanted to show. And let's see, we go to the schedule and well, maybe I can see the schedule. Here we are. And
I updated the schedule already.
you did it. Okay, then let's see. Let's see. I think no, then that's not good. Can you share the current
Yes,
schedule?
yes.
Yeah, that would be easy. So, which means
I have a video of Bill Ragsdale.
okay, yeah, if you want to show it, that would be great. And then we continue like this.
Let me see if I share it correctly.
Coming to you by the miracle of recorded delay. I'm out of town this Saturday, but I'm delighted to be able to present in any case. So the project for today is floating point number output formatting. I find that Win32Forth only provides FDOT for floating point output. That is one simple word, but you have very little control over the actual output format. If we set the precision to 6 and give it the decimal number 123.456, we can see the outputs. Now in the first case, there's 6 digits to a decimal point. The second line has 3 digits, 2 and 3, and so on for the last. We get 6 digits always output, and the decimal point will be wherever it is supposed to be. So I would like to have a much better degree of control over that formatting. First, I want to specify the decimal alignment. In the case we see here, the decimals are all aligned vertically, so I would specify I want 3 leading columns and the decimal point, and then everything would align to the left. This first case shows the number 123. It's been actually rounded to the tens. So it's 120 rounded to the nearest tens. Then 123 is rounded to the nearest units and so on. This number was put into a do loop with varying degrees of decimal representation. So that's what we'd like to do in our first case. The second case is I would like to specify right justification. In the case here, we set up a field, in this case 12 spaces wide, and again we take the same input numbers 123.456 and display it with varying degrees of right decimal places. The big discovery on this for me was that in the American National Standard Forth, the word represented is used to do floating point conversion. If we give it an address buffer space and a number of digits we want to convert, execute represent, and on the stack we will get the number of decimal places from the left, the sign of the number, and a potential error flag. That is that we'll get in ASCII bytes will be in a contiguous string with no punctuation, and we then can process independently from the exponent the sign and the flag. I'll note also that the flag is processed internally for error conditions. There are a number that are examined, like not a number, negative infinity, positive infinity, and positive infinity, and so on. But we do not have to worry about that. The flag will always be true. The example we see is again the decimal number 123.456, and we execute the word scratch, which is the buffer space. 8 digits represent, and this gives us the ASCII representation. The green at the bottom is a memory dump, and we see the ASCII values 31, 32, 33, 34, and so on, representing the numbers 1, 2, 3, 4, 5, and 6. At this point, and also we will then get 3 on the stack, 3, 0, -1 for 3 decimal places, a positive number, and a true flag for no error. This process builds on a fairly innovative, and I actually say rather obscure method to pass a local array between words. Theoretically, this is not possible, but they worked out a way to pass this buffer workspace between words. It's shown here in our code, showing the upper red arrow is a declaration of a local variable, and then the max string local allocation and $ buffer in the middle sets up a very large string buffer, and the 2 arrows at the bottom show how this buffer is passed between words. Enough about that. Our next need is to have right justification. In this case, we want the decimals, we want the word aligned with however many decimal points there are, but always with in a fixed width field. The primitive that does this is paren f.r. You can see the full code here, which I'll just touch on very briefly. In green in the middle is the word represent. This gets us the decimal exponent. Then the paren, the green paren f.paren is a Win32.4 primitive that does the bulk of the conversion. Then we just have to touch it up by adding leading spaces, which are done by the do loop in the middle. So to summarize this, the paren f.r generates this right justified string. Represent gets us the exponent. The paren f.paren formats the string, and then the do loop does the gross formatting by the leading blanks. Then the paren f.r is simply passed on to f.r, which is the actual user word, which does a conversion and takes the counted string and types it out. So we see here, sure enough, the result that we want. I'll note that the first 3 entries are actually off by 1 character position. The little needs a little bit of work, something I've got to go back and touch up. But these are all properly right aligned, regardless of the number of digits that we call for. The next need was for decimal alignment. In this case, handling money, for example, you want the decimal points to be all lined up. Sometimes you might be going to decimal dollars and cents. Sometimes you might be going to mils, which would have 3 decimal points. So again, we want the columns to be lined up on the decimal point. The words that do this are somewhat simpler because the paren f.a primitive actually uses the previously developed f.r. So we just do a little simple touch up here to do the alignment. And finally, the word at the bottom, f.a, is the word that the user sees in which the conversion is done and the string, the counted string is typed out. And we will see our result here. Sure enough, everything's lined up, vertically lined up. We started this off with a value of 3, which says I want 3 leading decimal places before the decimal point. The green arrows, notice where we have round off. Originally, I thought I might have to just handle the round off, and I would do it simply just by truncation. But I see now that the primitive I'm using from Win32.4 correctly does round off. The upper green arrow is at 1, 2, 3 decimal 5. Well, we know that the digits below that are 1, 2, 3, 4, 5. And so the 4 is rounded up to 5. The second green arrow shows us that the decimal fraction of 0.456 is properly rounded up, where the 5 gets rounded up to 6. So the little bonus about using the resident word inside forth is you pick up the correct round off. So to summarize, we see that there are tools within Win32.4 to assist us in floating point formatting, but it's a bit of work to enhance them. For me, it was a significant amount of effort. I mean, it was about 4 or 5 hours. I had to go back and read source code. Some of it was machine code. I had to decode this clever method of passing buffers back and forth. And now, once I've done all of that, I can make very rapid progress on the rest of my Win32.4 work. Unfortunately, there is no set of general primitives for handling floating point output. As we know, with integer outputting, we have this greater than, hash mark S, hash mark greater than sign. That allows us to do very flexible formatting for integers. We can put in decimal points, we can put in commas, we can put in dollar signs, but we don't have that available within Win32.4. I hope to get to that point of being able to add those into the system. I'll note in passing again that the F dot uses this cleverness to avoid creating a floating point buffer. And in the search for such a buffer, I came upon PAD, which we all know is used for decimal conversion. PAD is the output conversion for integer numbers from PAD downward in memory. I found, though, that PAD upward in memory has also been allocated for buffer space, and it's a 256 byte long pad, or temporary scratch space, and it is only used one time in Win32.4, and that is when it first initially boots up, a version number is printed out, and that conversion is done at PAD. And other than that one leading use for conversion, PAD is unused, so I have taken it over to use for floating point conversion. Well, that covers my presentation for today. I thank you for your kind interest. We'll finish up today, and thank you for your attention. Oh, incidentally, this is a cover shot of the book I'm working on.
Amazing presentation of
Nice, nice. Yeah, Bill, if you watch this later, great presentation. Thank you very much. Right. So, are there any questions?
Bill was in the meeting, but only over phone, and so he could not show the presentation. But now he's not. I cannot see him anymore.
He's
No.
not there anymore. Yeah. Yeah, but maybe if you have any question, next time he will be in the meeting live again, and he will probably be happy to answer questions also to his talk today.
Are we going to do a short coffee break, and after that continue, or should we continue?
I think that would be great. So let's see. A short coffee break, and yeah, we're only 25 minutes past schedule. That's great. I would propose something like 10 minutes or so, and then yeah, and then we meet afterwards. And Howard, I saw him in the chat. Are you prepared to give a talk on
Yes,
ColorForth? Yes,
I am.
Great. Yeah, we will see what is new with ColorForth, and yeah. So see you in 10 minutes. I would say you can keep here chatting, no issue, but the official part will continue in minutes.
Okay, see you then.
Testing, 1, 2, 3, testing.
We can't hear you.
We can.
How you doing?
Good. So you can hear me?
Yeah, of course. Pulling your leg there.
Okay. Excellent. I was able to
You're fine.
earlier, so I messed around until I. So
We have
thanks for
audio
the
and
good
video.
meeting so far.
What were you pose one question? Sorry.
So, all right. I stop sharing my screen, and then Howard, if you're ready, then the stage is yours. Sometime we wait a little bit longer. No problem. Ah, Howard, yeah, there you are. So,
Yes,
yeah.
I'm back with a coffee.
Yeah, that's great. That's great. And as I said, yeah, if you're ready, then the stage is yours. You can just start sharing your screen, and then we listen to ColorForth news.
Okay, so the first screen I want to share is what's new in ColorForth. And one of these screens should be it. I don't actually see it. Okay, let me just share everything and try and find it. Okay, that's since the hardware and Zoom and everything is determined to make it a challenge. I'm going to start with this screen, which is the screen that you get to if you go to inventio.co.uk CF 2023. Every year I try to do an update, add a little bits to it, and I come up with a brand new name every year. There's been, I think I missed CF 2020, maybe 2021, but there was one at CF 2022. Okay, so the first thing is I need to find the PDF file. Can you all see the PDF file now?
Yeah.
Ah, good. Okay, so it is working. I couldn't see this as an option in my screen share. Anyway, so what's new in ColorForth CF 2023 is I've added locate, which is a very nice feature that if you see a fourth word in your source and you want to know where it is defined. So we already have in CF 2022 that you can use the cursor to select a token, a word on the screen, and if that word is red, it will execute it. So now I'm going to try and do the impossible with Zoom and move over to a camera. I'm trying to think how I do this. I think I go to Zoom and I unshare my screen, presumably.
Right. And I think if you want to...
Stop sharing, that's it, okay, right. And then I have to choose the other camera, which goes into video. Oops, I mean stop videos, keep going. Video settings. There's the other camera. I love it. Can you see a blurred picture on the screen?
Yes, blurred.
Okay, the sun has come out in Cologne and it's coming through my window and it's throwing the camera. Hang on a second.
Mm-hmm.
It's the curse of the demonstration again. Okay. Well, it was working perfectly a few minutes ago. That's all I can say. It's a mystery. Okay, I'll take an alternative route. This is just like programming in ColorForth. You try to do something simple like set up a camera to view a screen, because a spotlight video favorite. Is that about? Oh, yeah, I know what it is. You can't share a screen like this when ColorForth's running, I suspect. Is there anything we can do about it?
Yeah, well, you can do try screen share.
Oh no, sorry. I know what it is. I put it blurred background. It's so good this being videoed, we can edit it all out later. Video settings. Of course, it's blurred background.
Yeah, of course.
Not that I'm stressed by doing this. Okay, virtual background.
No.
Background and effects, none. Yay, okay. I'm seeing it clear now. You all see it clear. Is that okay? I'm getting a whole lot of video noise as well, but that's normal for Zoom. Okay, right. Okay, let's try and start this again. If you go back a year, when I gave a little presentation of CF 2022, I had a problem with getting the camera to work because the black screen with the very bright characters, the camera couldn't handle it. So I was trying to improvise by putting an old pair of sunglasses over the camera, and that helped, and it was all very complicated. But so this time I thought, okay, I was trying to find a way of doing this that works. I thought, well, what I really need to do is I need to make the background white, and that will fool the camera into going into, adjusting itself so you can read the text. So what I did is, if I go into editor now, I made it a white background. Now, I don't think this looks as good, but at least it's readable. So I think that helps. I can go over to a screen on my laptop where it's running in a box emulator, And that is very clear, of course, but it's very slow. So I just wanted to do it here on this. You can see my fingers as well. This is actually a real, my other laptop. It's a picture of it. So what I want to show you is that I've added a locate function. So if I go forward, oh, sorry. Come on, back. Editor, next. Come on, down to there. Editor, right. I have no idea why this is so challenging today. Right. It's just...
In the US, we call it Murphy.
Yeah, I think so. Why can't, there you go. That looks more normal. Right. Yes, right. So if you go here, you'll see in block 64 here, the block is, I can't even see my thing. At the top right-hand corner in orange is the block number. So this is a block-based system, not a file-based system. You'll see that there's a word. So let me find a word that you find. I just realized I've removed the one I was thinking of. But just a simple example. If I scroll down to, I've being thrown by the colors. That's what it is. Let me get rid of this. Come on, back. Right. Yeah. So I want to go. Where's the cursor gone? Right, I'm moving the cursor here and it's now at the top left. So as you see, I can skip down here. So if I move to this word sect, I move the cursor just after sect. I press the enter key and it goes to where the sect is defined. This happens to be on the same block, so it's easy to see, but it works on any block. So it only works for words that are defined in the forth system, not for the kernel words, but that's something to do later. So where we go, so it's the same here. That's kilohertz. No, hang on, where's a good one? Where's low here? Okay, so I'll go low and there, right. So that was quite easy, and I explained why I did locate. But before I do that, I want to show you executing a real word. So if I go back to the start screen, as it were, I was very pleased to see that Peter has used my icons image here. If I move the cursor to the right of a red word, which is where it's defined, then it'll execute it. Oh my God. It doesn't work fully, I see, in this system because of the white background. I've used some white text in this little app. Okay, so the moral of this story is don't change the background. It's very difficult. Okay. Right. Okay. Where was I now? Right. So I now have an app in the main screen called Words. It's an app. I mean, it's a fourth word defined in one block, I think. So it's block 112. So if I execute it, something's changed the sea blue. Okay. It sounded like a good idea at the time, so you could see the screen, but I think the time has come to put it back. So let's. Sorry. So the easiest way of doing this, if I put to the other. What a strangely disastrous presentation. Okay. So if I put my other ColorForth, I'm sorry, it won't be so clear now, that's all I can say. At least I'll be able to read my own screen. Right. I want to get something where I can type by in it. Take a deep breath. Right. Now it should now reboot. This is operating from a USB stick, and I've just put my other USB stick in there, and it's loading. So you can see how quick it is now. Right. Can you see the screen now? Is it readable? Is it clear enough?
Better now, yes.
Okay, so this is the normal thing, right? I shouldn't have changed the colors. Anyway, here it is. So if I go to words here, there you go. This more works now. So what this is, words is a standard, and is it MinForth? Probably is, where it lists all the available words in there. So in ColorForth, you just got an array, a list of forth token names and a corresponding list of the code where it has to go to execute it. So it searches one and then jumps to the other. So these are the forth ones. And then there's the macro ones. It has two word lists. Well, it almost has three. Macro word list is one that's used to build other things, other forth words on the fly. Then it has the blue word list, which is a list of blue colored words that adjust the formatting on the screen. So I can do that with an F3. When you enable display of blue words, you can see them. And when you disable it, you can see their effects. So if I go maybe back to the main screen, if I enable the blue words here, you can see the minus tab means that words is on the same line at the halfway point. So if I go back here and I simply take out that's how it would normally be. So that's so it allows you to format the display essentially, which is very useful. So if I put that back, it goes back again, and then I hide it with F3. And just in case you haven't seen this before, there's an F4 function that converts it to more conventional forth. So when a ColorForth comment is just white, if you happen to be colorblind, this is obviously a problem. So pressing F4 puts it in colorblind mode, and it displays it as if it's conventional forth. It's still the weirdo ColorForth Shannon Fano encoded tokens underneath, but it's just an example of how you can do whatever you want in ColorForth 3. Okay, so I'll put that back out. Is there anyone in the meeting who is actually colorblind? But anyway, if there is, shout out. I'll put it back in again. But it's obviously it's easier to read for me. Right. So what is new in 2023? One of the major things is that I fixed a bug, or an unwanted feature, or a feature that could potentially have done unwanted things. And that feature was that magenta variables used to create their parameter field in the word list. And it was only when I was trying to implement words that I saw this. So if I go back to words, there, like so, what was happening was every time there was a magenta variable, and here there's, where are we? Oh, I can't use the cursor on the screen because there's no red words. So I can't point to it. I have to point with my fingers. These three, 4 L block, megahertz, X and Y, and these are 2 X and Y's as well. I didn't know there were 2. Okay, they are all magenta variables. And what was happening was that there was a blank space after each one. And I thought, well, what's that about? So I had to go into the code of how magenta variables work. So maybe this is the time to go back to the computer and show you another screen. So share screen. And somewhere here, there should be an edit plus thing. I don't see it. Are there? Oh, no, there's this one. I do see it. Okay. So just to, I'm hopping backwards and forwards. Can you now see a conventional text editor?
Yes.
Okay, right. So what I did to invert the background, I've got some hash defines, or what do you call them in Forth? You call them constants. In C, the hash defines, and here they're called EQs because it's assembler. So I changed what was 00 for black for the background to white, and what was white to black. But to make it work properly, I need to change all the others to make them appear nice. So if I undo that, so I actually did this. These are the other things I tried. I did this about half an hour ago. Well, I was thinking, well, how can I make this picture clearer? So then, in order to do that, I have to recompile it, reassemble technically with a C, bump, assemble, and then do go again. And that this runs box given the image that I've just created. So I've recompiled it, and hopefully we're back to a normal black background screen. I just want to say a year or two back, I was working with some very, very smart young German programmers, and they were horrified when I used Eclipse and I had it in light mode rather than dark mode. And this is a crime which is as heinous as wearing socks and sandals with shorts, which is also a crime in most countries I'm aware of. Now, this may or may not work, of course, because there's something locks the video. I'm going to have to stop sharing my video. Unbelievable. Oh no, it's just very, very slow because Zoom is hogging all the resources. Right. Can you all see a colorful screen now with a black background? I'm assuming yes.
Yes, yes.
Oh, good. Okay, so there it is. Right, where was I? Yeah, so I had the problem with words. Now, you see how slow it is, particularly with Zoom. That's why I was trying to do it on the other laptop. And you have to count and wait. It's normally about 5 times faster. So then I execute words. So here it is. Okay, so there was a gap, and it was so that's okay. The point I'm trying to make here, so I'm trying to get my brain into gear and stop being phased by Zoom and its vagaries, is that the concept of a magenta variable. Can we go back? There you go. So you can see these are in this purpley color. So megahertz, X, Y, L block is that the value of the variable is stored in the block in the actual source code, which is a very interesting idea. What I mean, I've been amused by magenta variables for many years, and it only just occurred to me when trying to fix this bug that the difference between a magenta variable and a locate field is minimal. So if I go to, so I'll just demonstrate again, but it takes a lot longer on this. So I'm skipping, I'm using the keypad to do this, but you can also use the down arrow key. And so if I go to megahertz, with any luck, oh, sorry, with any luck, I press enter, and it skips there. There it is. It tells you it's 15. And this would work over any block in the system. And so, if you think about it, when you define the magenta variable, it has to have a value of where the variable is going to be stored in the source code. So in this case, it's block 64 offset about, I don't know, 30 or something. So that value has to be put somewhere so that when you want to read it, you see the name. The name indicates, you search the word list for the name. The name is entry number something in the list. You skip over to the jump table corresponding to that, and that points you at some code, and that code has to find out where the variable is. In a normal fourth variable, it's just after the definition where it's compiled, but that's not how ColorForth works. So you have to do this. So what I did is I created a parallel word list array that lists where everything is when it's compiled, because that's what you need for the magenta variable. It's what you need to locate anything. So my point here is that it's a very strange connection between the magenta variable and the locate option that most forths have, I think, most big forths. Right, okay, now I'm going to go back to what else is new in 23. What's new to see in 23? And I've got to decide where that is. There you go. So the PDF, right, so this is what I was talking about here, pressing the keyboard enter key. So I'm trying to use as many of the keyboard keys that I know are always going to be in the same place. So the function keys F1 to F12, the enter key, tab, escape, these kind of things. I think they're always in the same place on a keyboard. You know, I mean an international keyboard, a QWERTY versus a QWERTZ versus a French one, etc. So for some time, CF 2019, I think, I introduced this thing that the enter key would execute the red colored token. So what it has to do is when you press enter, it says, okay, where is the cursor and what token is there? It says, oh, it's here. I'm here in this block. So I will look up that token and I will execute it. That was easy because there was already the list of tokens and there was the list of jump addresses to execute for each token. So that was easy. But then I just had to add for 2023 the locate field. And that now works, as you saw. Fixing this bug, this was weird. This was such a weird one because if you think about it, if you stored into a magenta variable, anyone, a value that happened to look like a Shannon-Fano encoded fourth name, it would suddenly appear in the word list and it would jump off to some code that didn't exist. And maybe this was already happening. There were some very obscure things going on. I'm not going to assign blame to this bug. It could be Chuck, it could be me. And I don't know. Anyway, it's fixed now. And I was able to see it because I implemented words, and words essentially printed out the contents of the word list. And then I could see there was a gap. And when I saw this, I was so confused. I thought, why is that? And the code is pretty complicated. So I also took the opportunity to document how it works a little bit in the code. Anyway, so that's now fixed. So I say it's interesting how locate and magenta variables are connected. Yes, the optimizing versions of and store. Sorry, corrupted by C. Fetch and store did not always compile code that worked. Now this is almost certainly me. When I changed the system from a 32-bit cell, okay, 32-bit cell to an 8-bit cell. So anyway, I've taken them out, and one day I will try and fix them. It optimizes the code, and since you get a speed up of 100 times by not using box, I think it's a little bit of a fine tuning. We had earlier, this was actually something I found in last year, 2swap and 2dupe. Somebody, Marco, I think his name is, pointed this out to me, and I had shifted them from the fourth source to the kernel in assembler. But I thought it was a good idea, but in doing so, I made a typo and they broke them both. So that's, and the GR demo works now. Oh, I can show you that. Hang on, come up. Where is it? GR, 1, 2. It would be good to see this on the real system. This is horrendously slow, but this always used to work, and I did all these changes and it didn't work, and I scratched my head. I spent a few evenings looking at it, and I thought, I have no idea what that was about. And then with all the other fixes, it suddenly started working again. And I posted on ColorForth. If anyone knows who wrote this originally, at the time that I included it, I'm not even sure where I got it from. It was somebody posted it somewhere, and I just added it to my distribution. I'd like to just put their name in, but I have no idea who it was. Okay, that's right. And let's go back to the PDF. Oh, did you see that, by the way? Could you see that? Never really sure what you're seeing compared to what I'm seeing. I think I chose to display what I'm seeing. I hope so. Or are you still seeing the words?
We see your source code.
With are there all the words white?
We see the assembly code.
This assembly code still. How can I see what you're saying? What is going on? This.
You shared a window instead of your whole screen, and so you're not seeing. That's the reason.
Okay. I think it's something to do with the alignment of the planets or something. This is a very complex day. Okay, so I need to go into Zoom, and I need to share my screen again. I have to stop sharing first, then I share the screen, and then I share the whole thing.
Entire screen here.
Is that working?
Yes.
Ah, right. Okay, so now if I do this, can you see the ColorForth code now?
Yeah, much better.
Okay. Oh, right. Where's the cursor gone? There. GR. There. Press enter. Right. Can you all see that now?
Very nice. Yes.
Very. It's very good. It's
bouncing ball.
Yeah, well, something like that. I think they're random filled circles and random unfilled circles on the left, and I think the ones on the left are normally colored. I'm not seeing any colors here, but yeah, okay, that's what I thought you were seeing, but you weren't. Right, so now if I go back to what's new, and I think if I actually stop ColorForth now, there you go, things will speed up a bit. Right, so now can you see the what's new to see in ColorForth 2023?
Yes.
Good. Right. So I was saying there's optimizing versions of fetch and store, and they didn't work anymore, probably because of the change from 32 bits to byte addressing in the entire system. And these was a typo. And this is actually this going back to CF 2022 is already there, but I thought I'd have to put something else in this list just to point out that it still exists. Support for encoding and display of ASCII characters, and the fonts in ASCII order and so on. And there's some links here. I just wanted to show people, if you go to my website, how you can try this out for yourself in a Windows machine, or if you don't have Windows and have a moral objection to it, then you can also run it directly from a USB stick or under QEMU in Linux or whatever. So so these are all the files. I've updated how to program in ColorForth CF 2020. Okay. This is last year's. There's a problem with the redirecting a file. Okay, let me get rid of that. It should work, maybe with a Shift F5. Curious. Anyway, CF 2023. This is more like it. It's amazing, isn't it? Everything that could go wrong is going wrong. I feel I'm going with the flow now. My expectations are lower. So this is how to get it. This link is to the ColorForth archive, and this is a link to the roomed zebra version from the 4th of the 4th. Of course, I worked at getting it finished for the 4th of the 4th. Last year, I managed it by the 8th of April. I was a few days late, but so this is the documentation for it. This is what's new to see, and this is how to program in ColorForth CF 2023. And this I'm trying to explain to people what you have to type in order to make it do what you want, which is largely about this keypad here, using the keypad rather than the keyboard. Okay.
I have a question for you.
Yeah.
Is ColorForth written in assembler or Forth?
It's written, the kernel's in assembler, and I made the decision to move quite a lot of stuff into the assembler side. If you think of it as it's like a two-tier system. If you think of this, the horizontal line that's on the screen right now, the bit above it is the ColorForth source, and the bit below is the assembler. And I've shifted quite a few things from the 4th level down into assembler for various reasons. One is that I don't have an assembler in the 4th system yet. Chuck felt or feels that it's okay to have just hex opcodes in your source as an assembler. And I have an open mind about this at the moment, but I prefer to have named assembler words. Maybe one day I'll add that, but it's a big job. Yeah.
What is the advantage of ColorForth over a standard Forth?
It's the simplest possible Forth or possible system that you can have. Everything you see is assembled from one assembler file. This one here, I'll go to the top of that. Hang on, let me get rid of this so I can see my own screen. Right, so this is the assembler file. It's about 8,000 lines, which is kind of a lot. What's it currently? Yeah, 8388. But it's all there. This is the entire ColorForth system that boots and is then, let me go to, I'll take my glasses off this. So for the other laptop, I need glasses. This one I don't. And if I go to somewhere here, CF says nasm.f somewhere. This one. Okay, so then this is a normal ASCII text representation of the ColorForth that you'll see in color. Well, this is also in color, but slightly different colors. So you can see this is the same thing. This is block 64. This is its name, and so on. So this is Forth, and the assembler is not Forth. And I would much rather, what I would like to do is to create an assembler in ColorForth and have it assemble itself. That's like the holy grail for me, being able to do that. But at the moment I can't because it's various issues. But I think that doesn't really answer your question. The real answer is it's an experiment. It's a place to explore how things work. Like, do you want to have magenta variables? This is an interesting concept because it is possible to implement them in other environments. Now I'm going to try and run ColorForth again, but it's not easy. It's very easy in ColorForth because it uses blocks. And I'm very interested in the way that when you create something that helps, somehow you you block off other options. So these days, everyone uses files, except a few people like in VolksForth, presumably, and ColorForth, and a few other retro style forths where they use blocks. Now, I don't like files. I never have liked files because I started my career without them, and they came along and they made everything harder. So it's so slow. It's unbelievable. This is Zoom, I think, taking a lot of the computer resources.
So let me ask you another question.
Yeah, okay.
And I'm sure you're going to figure out why I'm going here.
Okay.
So, so with our Core 1 project, we're creating, fourth opcodes.
Yeah.
How difficult would it be to write ColorForth in fourth opcodes? Instead of assembler.
You'd have. I'm having to think about that, because what do you mean by write ColorForth?
Well, at some point when you write a fourth, you create the primitive words like dupe swap, stuff like that in assembler, and then you create this core of, say, 25 words. I'm just pulling that out of my hat. And once you get those 25 words, you write the rest of the fourth in fourth. So if you're going to port a fourth from one processor to another, it's only those 25 core words. Now I'm talking conceptually. I don't know ColorForth that well. So I was wondering if, and the other thing with the Core 1 is you can create your own opcode. So if you had certain assembler words that you really liked, that are non-fourth type words, you could very easily add those and make them part of the instruction set, so it'd be easier to code your ColorForth. I'm kind of exploring as to whether you could move this onto an FPGA.
Okay, that's a very interesting idea. Sorry, somebody said something I couldn't quite make out.
Yeah, is he talking about macros to extend the instruction set of the assembler?
No, well, in system, you would
No,
write
I would say the 25 words that you're talking about, what the beauty of ColorForth is that those 25 words are just a dispatch table in ColorForth. So ColorForth is even simpler than the typical fourth virtual machine. It is just a dispatch table of these 16 colors, and that's the whole interpreter. So in some ways, it's a simpler system than even a traditional fourth.
Yeah.
So it'd be simpler. It'd be simple to write it in system Verilog then.
Very possibly, yeah.
Yeah, I'm sure it would be possible to do it. I'm having problems. Nothing's working. It's amazing.
It's demo time.
It's demo time. Okay. Wow. I think maybe I can't explain why that's not working. Okay. Okay. What you're asking, I think, Don, is how easy is it to port ColorForth to a different processor architecture?
Correct.
Okay. There's an awful lot of code. I mean, the work required to port ColorForth pre-2022, I think, from a 32-bit cell addressed system to a byte address system was enormous. And there's still applications that are not quite working. And that was just on the same processor, but just doing it in a slightly different way. I'm quite happy that I went that way, because ultimately I want to be able to use other people's code, and everybody else in the universe uses 8-bit addressing. So, but that was a hard thing to do. So the answer, I would say, is extremely hard. That's good. I mean, the easiest way for you to do it would be to emulate an x86 processor, and then it would just work. But then
no, that
you're getting into the whole area here of what you're trying to achieve, because
I think I guess I would argue that the core ideas of ColorForth are very simple and could conceivably be translated. The one exemplar we have of a full ColorForth system is built on the particulars of the device that Chuck was working on, and the various things that folks have layered on top of it. And so porting that high-level Forth code, which is it assumes a particular machine, would be very challenging, I think, is the.
Well, porting the high-level Forth code would be very simple. Are you now seeing my other camera? Well, I'm seeing.
No, we see your ColorForth.
Yeah.
I propose we can continue the chat after the meeting.
Yeah.
In the Forth Cafe, because we have Cecil Bayona, who will present us how to write a C compiler, and it's also a very amazing and interesting presentation. And I invite you, you still have in the group your corner for ColorForth, because I think this is an amazing piece of code of software, and it deserves more presentations. And you do this fantastic, and
not today.
Not today because of the graphics problems, but next time you will have these problems resolved probably.
I think Übung macht den Meister with these things, and I'm getting to master Zoom. Just to reflect, the problems today was that I put on a blurred background, and then of course I switched to my other camera to show you the nice sharp characters, and it was blurred. I mean, it's all computers do tend to do what you ask them, and I asked it to do that. That's not what I meant.
We are delighted to listen to you and to see your demos. And please, next meeting, if you have time, please continue next time with second part of this interesting demo.
Yeah, I'll try and work out what the answer is to what Don asked. I mean, lots of people ask me what is ColorForth for, and I have real struggles to say what it's for. What it's for me is that I can plug a USB stick with the image on it into a laptop, and I run a program that I can edit code, write programs, make it run, which is completely independent of any other operating system. And it's not really an operating system. So that's one of the main features. Yeah. And it's very, very simple, conceptually very simple. As Brad said, there's just the dispatch table, and that's what it is. Or actually, and there's also in parallel with the word list and the dispatch table, there's the locate list as well.
This is fantastic, Howard. We love it. Excellent.
Okay, thank you.
Now, our next participant is Cecil Bayona, who will present how to compile a force in a C. And please, if you can share your screen, Howard.
Did it already.
Okay. So somebody has blocked my video as well. So if you want to see me, Ulrich, you'll have to.
I have to
re-enable my
video. Okay.
The host has asked me to start my video. Okay.
Okay, can I go?
Please.
Yep.
Well, first of all, I guess you didn't get my message that my presentation wasn't about how to create a Forth compiler, but how to create a compiler that's unusual called MinForth. And the min in MinForth is stands for minimum, but it's not minimum in capability, it's minimum in the resources required to create the compiler. So I did not create MinForth. I can't remember the name of the person who did. And here it is. Can you all see my screen pretty good?
Yes.
In this particular case, MinForth is compiled to be a 64-bit compiler for Linux, which is the operating system I use. And you notice it got 128 levels of data stack, return stack, floating point stack, and 1 megabyte for just free use to create variables and so on. Okay. Now, this is, if we go here to a browser, this is the source to MinForth. You got 2 versions, Windows and Linux. Okay. I'm going to be working with the Linux version. It takes a compiler to create it because the end result of this is C code that needs to be compiled with a C compiler. And most people use GCC in Linux because it's included with every version in the universe of Linux. But I decided to use the tiny C compiler. Why? Because I'm a contrarian. GCC is a very complex beast that sometimes creates programs that don't work. It optimizes too much. This guy, TCC, doesn't optimize super a whole lot, just a little bit, and it's extremely fast. It's about 10 times faster than GCC. So when I'm working with it, it's fractions of a second to compile a program. Okay. And what else do I have up here? Some of the test programs I'm going to show come from Rosetta Code. Okay. And that's where we stand in the universe. So I'm sitting here in a directory that when you get the source code to Linux and you unzip it and put it somewhere, this is it. It has a Linux folder, which I took and I copied all those files to the main source file. The reason being the main source file is for Windows. These are the files that are a little different for Linux. So I already did that. And if you look at my screen here, see these files that have an asterisk for as part of their icons. These are executable files. And I have MinForth. And now I don't, because I just deleted it. And when I click on the icon, nothing. So what's weird about MinForth, I've written Forth myself in C. And in that case, written in C is about 30 primitives, enough to give a compiling compiler, and then the rest of Forth gets sucked in as an include and compile, and compiled by the Forth compiler. That's how most C compilers that are used for Forth do it. These guys did it a little different, and I kind of like it. Like I said, I'm a contrarian. So here's the procedure to build the C compiler. And one of the things they tell you, okay, let me get out of here for a second. Okay, I open the command window in that folder, and the first asks you to test to make sure your compiler is okay. They have a really not much of a test. Hello.c. So I created there's a make file here. Oops. I gotta remember I'm in in Linux. I want to tell it to compile, link, and create an executable file for a file named hello. Boom, it did it. I'm telling, this is a fast compiler. So if we look in here, all of a sudden an executable shows up. And if I execute it, hello, it's alive and well. So now I can proceed to build the compiler. So the first step is to compile the transpiler. The transpiler is a program that takes, written in C, that takes a combination of C and Forth and compiles it all into C code. Okay? Now I take that guy and go in here and tell it to transpile it, to compile it. Bingo, it did it. And now we look at the code. Oops. Now we have another executable, MF42C. Okay, Forth2C. And now I can run that guy. Now the way that works is you can give it an optional parameter, which is the file that you want to transpile to C. But if you don't say anything, it assumes you want to compile MinForth. And that's what I'm going to do. Boom. And the MinForth code for the forth, I don't want a lean system that's useless. I loaded all the libraries, okay, in one shot. So I compile them all to C code. The core forth, memory handling, searching, string, double, float, complex numbers, locals, file, block files, extra tools, overlays, and editor. All those things got compiled, okay? And it gives you down here 784 words, 130 words that are headerless and are only used internally and not available to the public, okay? And so what did it do? It created ms3.c, a file in C that's the Forth compiler. And it's going to have some weird stuff in here because it's Forth code translated to C. So you can see, for example, this would, let's see, something that you simple to use. Cell, okay. Cell executes this routine. It pushes on the stack and it executes that routine. And the next thing we do is we compile that C file that it generated. Now, the advantage of this approach is you have that transpiler takes a combination of C and forth and generates a C file that can be compiled. You can use that with other things. Like if you have a program in Forth that's debugged, you can use that to generate an executable that doesn't have Forth inside. It's just executable code that runs your application. Somebody can't dig in and find out what your source code is or anything. So that can be handy. So we go back here and we tell it, compile MF3, MinForth 3, the source code. Boom. You can see how fast this thing is. That's one of the reasons why I like it. Okay. And now if I execute MinForth 3, it's alive and well. Well, you know, you can say maybe it's alive, maybe not. Your typical words, a gazillion of them, 700 and something words. Okay. So if I do one myself, let's see. I got some real simple words here to test the compiler. It's a routine that I always use all over the place to test the video. And what's it doing? Something and 0 do. It's going to loop something times, and then from 127 to 32, do another loop inside that loop, get the index of the loop, send it out to the screen, loop back, finish with a carry return. Now, 127 to 32 is the ASCII alphabet. Okay? So I go in here, I paste it. Oops, don't want to do it too many times. A 1,000 alphabets. An alphabet. So it compiled that correctly. Okay. So what else have we got in there? I like to shut the little sucker down so that
Cecil,
these, huh?
It looks like CR is not doing what it's supposed to do.
What?
CR is not doing what it's supposed to do.
CR is the carriage
some
return
reason.
of the whole thing.
No, CR is carriage return normally.
But
It's
I'm
weird.
not carriage return in between every line of the alphabet. It's at the very outer loop. And it does a carriage return at the end of the program to that OK doesn't come next to a bunch of alphabet. Okay.
Okay.
So now here's an interesting test. Not every program in the world can survive this. But MinForth does. This is a program I should not have done that. This is a program that goes in a recursive. It's a recursive program, okay? Munge, add 1 to whatever's on the stack and recurse, go back do it again. And this program, in some cases, some forth, if you sit there and do a recursive program with no end, you're going to crash the system and you have no idea what your limit is. But apparently these guys test for stupidity and it doesn't crash the system. I can recurse a subroutine 126 times. So if I'm doing something that I know is going to require 1,000 times of recursion, this ain't going to do it. I'm going to have to increase my memory. Okay. So we got more space for the stack. Actually, I'm going to have to increase the data stack because this data stack is going to contain a bunch of variables and the return address is going to contain a bunch. And it's going to blow up my program, but there's a place in the source code where these are constants and you can go and change them, recompile it. And that's why I showed recompiling it. And you can modify it that way. Or if you add another library that you want to be included, then you will go to that simple procedure of creating a new copy of MinForth. Now, the transpiler, this guy, does have some limits. It will not take a loop inside a loop. It will not accept it and will give you an error telling you that it won't take it. And one of the future projects would be to change the transpiler so it can, right now it uses variables to hold the values and then it goes inside the loop and then it loops back. It should be using an array and an index to where inside the do loops you are, so you can have multiple a do loop inside a do loop inside a do loop inside a do loop. And, you know, whatever, a reasonable value. Forth programs tend to be small little routines, so hardly ever do you have, for example, 8 do loops inside each other. I mean, that's just not done. You need to factor your code. And you got other things here, for example.
How about using a loop stack?
Huh?
How about using like a stack, a loop stack, instead of an array?
Well, there's ways to stop and exit a loop and things like that. But if you think your program needs a do loop that goes a whole bunch of times inside a whole loop, do loop inside a do loop, you're crazy. You need to fix your attitude. Here's an interesting little program. And it's a multiplication table. Bingo. Except you notice, even though I'm in a terminal, I use color because it has words to change the color of the terminal and so forth. So the elevator routine here could have multiple colors or something. And I'm thinking for the next part is if you do even though the contest is over, I don't care. As a sample program, create an elevator in color, like some of you guys have done, and then go through. And this is not for advanced people. This is a little program for people who are just getting into Forth, and then explain how the whole thing works in detail. So that's it for now because I'm into 20 minutes. So thank you very much. MinForth is free. Yeah.
Can you show us, does this generate source code that we could read? In other words, if we go and look at, let's just say, you know, a do loop in Forth, can you go and open up a C file that shows the translation into C?
Well, this is what it does right now. I don't, this is the generated code for MinForth itself, okay? A bunch of declarations of the routines, because C doesn't like you calling a routine before you declare it, so you're pre-declaring the routines, and here's what they are. And let's get out of here.
It almost looks like it's a table.
Yeah, and here, what is Forth? It has a dictionary, which is a giant table.
So these numbers after the void is the index into the table, right?
He's creating random numbers for the function names.
Oh, he's just defining it. Okay, got it.
That's the name of the function in C that does logo, you know, underscore logo. And if you keep going down, for example, here's some code. This is to@, and it makes a comment of what is it you're compiling, and here's the C code that does it.
That's nice.
Huh?
That's nice. Yeah, we've been toying with the idea of a Forth to Verilog compiler. This is almost would do that.
It could, but you're going to have to change it. Here's the word count, which is defined as Forth, and then it tells you that it's this routine, which means dupe, this routine, which means 1+, this routine, which means swap, and so forth. So you can see what the compiler is doing. It just has a couple of limits. One is you can't do a do loop inside a do loop. And I'm thinking that'd be a nice project to fix that. And then you could just take any Forth program and go spit out a C code that you don't have to include the Forth itself. It's just the, now, this also makes it easy to, and the reason why I'm using this, it makes it easy to migrate to another system. I'm thinking of migrating this to CPM 68K. And if there's stuff in the C compiler that doesn't quite work, I can change the transpiler so it doesn't output that stuff that doesn't work. And be able to compile it, put it inside the 68,000, run it through the C compiler, and bingo, I got a 2012 ANSI compatible compiler with all kinds of extras.
Can
Anyway,
you show us the transpiler, like the source code of it?
The transpile? Okay.
The source code for it.
Oh, the source code for the transpile. Here it is. Okay. It's a C program, completely in C. And let's see. It got a structure for the dictionary because it has to build a dictionary for the words it's going to use. And let's see how it's not very big.
Wow.
And here it is. Here's doing some compiling. If is this, generate that, which is a call to that function. And that function can be defined in some other language, and therefore it would output in Swahili or whatever.
System Verilog.
You would have to go in here and modify this, and it's pretty straightforward.
All right.
Okay. So yeah, you could take that transpiler and modify it to output some other language other than C. Go, Rust, Verilog, okay? And it's not horribly hard. It's just, if you see this, do that. If you see this, do that. Output that. Okay? And here it is. If you see variable, run the code, do variable, you know? It's pretty straightforward. So the whole system, the way they did it, even though it's a little unorthodox, has possibilities to do other things with it that are kind of nice. And like I said, the do loops store the data in variables. Instead, it should store them in an array and index into it as to what level you are in. Everything you hit a loop, you decrement that thing and go up to the next level of the loop. And it's not a major change to do that. And I like it because it just has a lot of possibilities.
Yeah, for sure.
Yeah, and this is the kind of junk I've always liked playing with rather than applications, okay? It's compilers and tools and word processors and things like that.
So in your spare time, make a Verilog compiler.
I have no use for a Verilog compiler. Actually, I could because I have a whole bunch of FPGAs that it'd be nice to create a CPU with them. A lot of Lattice. I really like Lattice. Several Lattice boards I have, and
So do I.
And then what is it? What are the other names? The big ones, Dylink and
Altera.
Altera. I have
Microsemi.
several of those, but those are huge boards with, you know, 100,000 LUTs. You know, what can you do with 100,000 LUTs? Well, here's a 32 CPU machine, you know, whatever. You got enough horsepower in there to do that kind of nonsense. Anyway, that's the end of my presentation.
So Peter,
it's kind of a nice system, you know?
I think it's awesome. I'd like to hear more about it as you go forward.
Well, we're going to deal with it a little more in the future.
So at some point here, I'd like to give you a little update on the Core 1, and I think, Cecil, you might be interested in what I have to say. So, Peter, when you get me scheduled in you know, in the remaining time frame.
Yes, Don, go ahead.
Okay. Let's see. It says somebody's sharing the screen. It won't let me share.
Me,
oh, there we go.
me. I'm guilty.
It's okay. All right. You're seeing my whole screen, I assume.
Yes.
Yeah.
Okay. So first we're going to start out with so Dimitri and I have been working on the Core 1 for probably a year and a half, I guess, you know, because we both have real jobs and we're doing it part-time, but it's really coming along. And recently, the system Verilog code that Dimitri has written is pretty healthy from the standpoint of you need to really know system Verilog and FPGAs, but that's the hard part. So he's done the hard part of the coding. It's very easy to add your own opcodes and to write your own system Verilog code. So here you define your opcodes. These are just basically like pound defines in C, but you define whatever opcode you want. And then the part that I want to talk, okay, and then you can have an embedded system where you don't need any external chips at all. You don't need external RAM. You don't need external ROM. You can actually, the entire Forth processor fits inside of a $5 FPGA, and you only hook up a serial line to it. The outer interpreter compiler is now fully built into the system, and that was not a trivial piece of code. It's probably taken 6 months for that. But here's an example of, you can actually build Core 1 cores and have them execute internally. And you can put multiple Core 1 cores inside the FPGA. In this particular one we've been developing on, only has 5,200 5,200 LUTs. Those are logic elements. And the full Forth computer is only 3,500 LUTs. So the Core 1 is, you have a boot ROM and you have RAM, and then you microcode your program like this. That is probably only 13 to 1,500 LUTs for just a straight Core 1, processor. So that's like the J1, or it's like any of Chuck's Forth processors, like the Shaboom and the RTX 2010. But we took it a step further and we added an outer interpreter. So here's the Forth outer interpreter. This is not for the faint at heart. This is beyond my capabilities at System Verilog. But Dimitri got this all working. So it uses a state machine, and basically one state is you parse it from the RS-232 input stream. And so he's got some other states here, before link, get link, and then searches to see if the word is in the dictionary. Add exit. So if it's a semicolon, you need to add an exit. Get XT. That XT is execution token. So we consider things execution tokens. Now you can have either an opcode in your. You can call an opcode from Forth, or you can call a CFA, because it's totally different, right? A token and a CFA. When you write your own words using colon, semicolon, it compiles CFAs. It doesn't compile tokens. But so this allows us to have a super fast inner interpreter that just simply does a fetch execute via tokens, or a CFA, which would have to do, add one more clock cycle. And then you have execute, and then you also have a state called compile. This is where Dimitri has been working, and it is all working now. So this is kind of a software update. Here you can see some words like over is basically one line of code of System Verilog code. Dupe is one line of code. It's all C syntax. I'm sure everybody can read that. We created our own opcode called IOLAB, and basically these registers are tied to output lines on the FPGA, and so IOLAB actually grabs the data on the stack and then outputs it to the IO line. And here's where you're doing input. This is an IO button. So it's actually inputting button 1, button 2. These are IO lines on the FPGA, and then it puts it on the data stack. Excuse me. So you can see it's so easy to create your own opcodes in this. This is actually O branch, which is the fundamental opcode in a Forth processor for creating if then and while statements and such as that. And of course, this is looking for a 0, and then branch is looking for non-zero. Here's an example of a MIT. So in system Verilog. So it's really interesting. You can create an entire embedded system using a $5 FPGA. It uses internal ROM inside the FPGA, internal RAM, and it would be running over 100 megahertz for $5. And you don't need external RAM or external PROM using this system. Is there any questions on software before I go and show you the board?
Yeah, when you compile, are you compiling to the RAM or are you compiling by creating new FPGA code?
This is compiling, this is synthesis code. So it's actually programming the configuration file, for the FPGA. And all of this code creates circuitry on the FPGA. This all turns into circuits.
That's awesome.
And that's why I was querying you about your trans compiler, because basically if you could create system Verilog code, which is almost identical to C.
Yeah,
it's very close. And because Dimitri and I thought it would be really cool if people could write code in Forth and actually have it create circuits. Now Brad and I have had a conversation. He had a fantastic idea. It's something I've kind of known about for a few years. I wasn't sure how far it's gotten, but there's a concept of reconfigurable computing. And what that means is you can reconfigure the configuration file and change the FPGA. So Brad and I both have been kind of looking into this, and I was amazed. You can actually do incremental reconfiguration. And so I'm working on a development board, which is what I'm going to show you next. And I'm going to put the capability for the ESP32 to control the FPGA's reconfiguration. In other words, it will emulate the flash where the configuration is normally stored, and it could literally it could change the configuration and add circuitry. And it looks, I think it can add it on the fly. We're not quite sure yet, but it kind of looks like it might be able to do that. It's be an extremely powerful tool to be able to do that. And what's cool about that is you could write Forth, and it would basically, Forth would be the synthesis tool. How about that? And I remember at the last Forth day, and I asked Chuck, I go, have you ever thought about working with FPGAs? And he said, no, because they won't let me use my tools. Well, if you can program in Forth and it creates circuitry, that's his tools, right? So maybe we can get Chuck involved in this. I don't know. It would be an extremely powerful thing that only Forth could do. Well, I guess I shouldn't say that, but because Forth is incremental compiler, and if we can incremental compile circuitry, that would be something else. So this is this is a, maybe I'll show you before I go into the circuitry. Let me show you the board. Let's see. So I've been working on this full time for the last 2 months. I lost my my last job. Company shut down operations, and I had a 2 months in between jobs, and I've worked literally every day on this. So if I were to if this was a customer that came to me and asked me to do this job, I'd charge them 25 grand easy for this. But I'm doing it for free. It's going to be open hardware. And this is the oh, let's see. So this is the ESP32. I'm using one of the SOM modules. It's actually the more powerful one with the PS RAM, 16 meg of PS RAM. It has dual processors. It's got Wi-Fi and Bluetooth. So that's our interface to your cell phone and also the internet. And then I have a very powerful FPGA, and this is something else. Let's see, let me turn everything on. This was really hairy. So so you can see I got a 6-layer board, and I had to escape all these pins. The pins are very close together. That's kind of hard for me to move it around, but it was quite a chore getting all the signals out of this guy. So it's got this chip over here, or the chip that's on top of it, these red lines here. Let's see. I got the silk screen. So this chip here is high-speed SRAM. Now this chip was designed to be cache memory for PC motherboards. It has a 4 nanosecond access time. So that's about 250 megahertz operation. The FPGA can go about 250. So that means that the external SRAM, which is 64,000 by 36 bits wide RAM, can actually operate at the speed of the FPGA. So when you run Forth on this guy, it would smoke a PC running Forth, absolutely smoke it. Because a PC uses DDR memory, and it's got, you know, all the overhead of Windows or Linux doing its thing. So 64,000, yeah, and it's 36-bit cells, so you can fit a lot of source code in there. This chip down here is flash memory. So this has 2 gigabytes flash memory, and it's a by 16 interface. So it's parallel flash, which means you can access 16 bits at a time in 45 nanoseconds. So it also has an SD card on it. So down here is your SD card. These sockets here are for Arduino shields. So you'll be able to plug in an Arduino shield on this board and play with it using either the Core, the Core 1 FPGA or the ESP32. And basically what you do is, since they're both chips are connected to these pins, you got to make sure that whatever chip you don't want doesn't have access, you got to make sure their IO pins are configured as inputs. Otherwise, they'll fight each other. But so you have the ability to play around with Arduino boards. Now these two connectors here, and actually here, are for a daughter board. So I'm going to, when I finish this, I'm going to go on and design a Whiskers 2 board that plugs into this board. So the Whiskers 2 is my intelligent mobile robot, and we could create boards for doing vision systems, all kinds of things with that. You could even put more memory and stuff on the daughter card. There is, okay, with FPGAs, there's a thing called SerDes, and it's basically a super high speed. It's like in the gigahertz range, like 2 or 3 gigahertz serial interface that FPGAs support, and it's differential pair interface. And so I brought that out to 2 USB connectors, which are over here. So that means you could daisy chain these boards together. If you want to build a supercomputer, you could just daisy chain these guys together and experiment with that. Here you have the 2 serial connectors. So you have one serial port, so to use can use a terminal on your computer. One's hooked to the ESP32, one's hooked up to the FPGA. So you download your source Forth code into the FPGA using this port here. Let's see. I don't have all of the so here's a picture. This is the top side of the board. Now these daughter card pins, they're installed backwards, so they should be on the bottom side of the board. But anyway, so that's the top side. It's got a lot of chips and stuff on it. And then that was the top side, I mean. And then this is the bottom side. This is where your FPGA is. And we have our power supply over here. So I'm about 90% done with this thing. I got 130 unconnected nets right now, and I got some other stuff to do to it. But I'm going to be sending this out for fabrication probably within the next week or 2. I was trying to get it done this week, but I got kind of sick. Let's see, anything else? So, let's talk about the FPGA for a minute. So I moved up to the EPC 5 FPGA that can have up to 85,000 LUTs on it. You can get an 85,000 LUT chip for $45. What I'm going to put on there is a 25,000 LUT chip. Now remember, the Forth processor, which includes the outer interpreter compiler, only uses 3,500 LUTs. So if you're using 3,500 LUTs out of 25,000, you could put in the core 1, just the micro-coded core 1 core only uses about 1,500 LUTs. So you could put on a 25K chip, you could put 1 Forth computer and maybe 10 core 1s. And these are true 32-bit computers, right? They're not stripped down. And then each core 1 would have its own boot ROM and an SRAM assigned to it. In an FPGA, you have both SRAM and you have ROM. So this would be one powerful board. Now the 25K chip is about $17. If we found an application that would need 40 core ones on it, for example. You know, if you wanted 40 core ones running at between 100 and 200 megahertz, and most forth instructions will execute it within one clock cycle. We might find some mathematician or something, you know, somebody like that who could utilize that many cores. I personally wouldn't have an application for it, but at least not today. I can't think of one.
Yeah. Don, there are actually questions in the chat. Do the core have IPC like queues or semaphores? The cores?
Okay, so how would you hook up the cores?
Yeah.
Okay, so there's two ways to do it in an FPGA. One way is you create an internal network, and I was thinking something. If you guys remember Token Ring, so ArcNet, yeah. So one way is to use like a token ring network, which would run extremely fast inside of an FPGA. It'd running at 200 megahertz. Or you can use what's shared registers. So in an FPGA, you can only have one system driving a register. You can't have two different processes driving the same register. So what you would do is you create an input and an output register for each one of the core